Hey guys, welcome to SkyTour LiveStream here on July 28th, 2020, and I am here with our special guest.
All I hear is music.
Well,
What?
You shut up. I think we can make that music go.
Oh,
Hey, what's up?
I hear you now. Okay.
Yeah. Well, you just have to turn yourself up too.
Okay.
So I'm here with, as you can tell, Keith from P&K Space Imaging. They're supposed to stream tonight, but unfortunately, apparently they got clouded out. I'm going to say, hey, look, to the first ones. Brandy is here. Cypher 2. Cypher 2 was here like an hour ago. I guess, Cypher, man, come on. It's like, you got to eat dinner at least, right?
Thanks.
Andy is here. Daisy and Zoe are here. It's an early start. Hello, Dagger. It's an early start because we're just going to be looking at the moon tonight. Maybe a couple other things, but the moon primarily because it's really kind of a lousy night for looking at things. But you know what? I figure, look, we got a moon. Why not, right?
Why
not? Yeah, and Keith, of course, is always a why not kind of guy. So, hey,
right?
Why not?
I love the moon.
That's right. See, Brandy said hi to you.
Yes, and Brandy got some good news this week, so good for her. And of course, let's see. I know Andy, and I know Dagger, of course, and Marco.
Yeah, Marco's here. Hey, how you doing? I talked to Brandy at length the other day. Actually, she had an issue. I tried to help her out, and we got a bunch of people that are kind of just waiting in the wings here tonight. It's sort of fun, and we figured, it's gonna be kind of a rather easy going night. Okay, but something. If you guys do have anything you want to see and it happens to be up, well, guess what? We'll check it out. Why not?
Yeah, let's sky tour the moon. Let's look at the Apollo sites and stuff.
Yeah, I wish we could look right at the Apollo sites. If we could do that, I would have the most famous telescope on the entire planet if I could do that.
Oh yeah, but according to some people, you can look right at you can see everything on the surface from Earth.
Yeah, and apparently there's even vegetation and forests.
Yeah, and clouds and
yeah,
all that kind of stuff.
Yeah, I can't.
Wrong, Mark.
I know. I guess I'm behind the times, huh?
What, 40 years of astronomy? Jeez, I figured you would have caught up by now.
Well, I'm sad to say it's more like 45. But
you're old.
What can I say?
Aren't we all?
Well, the thing is, though, it's like this.
Damn.
Astronomy is older than me by a long shot, okay? And the universe is older than astronomy by an infinite amount, almost, compared to the existence of humans. So, none of us are really that old when it comes to the universe, right? So, we're all babies.
Yeah, whatever makes you feel better.
Yeah, hey. I think that was a smart.
That was actually. It kind of made me feel all warm and tingly inside.
Okay. No, that's because you had an accident, but that's okay.
Whoops.
Gotta get those adult diapers there. Yeah, Keith, come on.
No diapers needed, because as you know, never mind. I'm not going to go down that path.
I know because I don't. As I know, I don't know anything. Hold on, that's TMI already. Too much information.
I'm not going to try to bring up the shiny, honey.
Yeah.
You're going to make me.
Here we go.
Tried to leave it off.
Andy Morrow's talking. Andy Morrow says it's a flat moon. You're right, Andy. It is a flat moon. Yeah. Earth is flat. The moon is flat. Yeah. I know he doesn't really believe that. He's trying to just be funny. But
yeah. Andy's a comedy guy.
Yeah, he's a comic without the laughs, right?
You know what's crazy about Andy?
He's a good guy.
And Andy, I'm going to talk about you for a second here. I see him everywhere. I see him on Facebook. I see him on Earth Radio. I see him here. I see him on P&K. Never once said a thing to the guy.
Never said what?
Never said a word to the guy.
Talk now. You got your chance.
Spoken. Like I never heard his voice like on the radio. Does he host a show or does he just play music?
I don't know.
I have to ask him, Andy.
Well, he's here. Ask him.
Yeah. Let me know. Because I just see you posting everywhere, but I know you had a radio show on Earth and
yeah.
I didn't know whether you talked on it or, so yeah, let us know. And if you do, or if you have a show, be sure to put it in the chat so people know.
Yeah, exactly.
Spread the love.
Yeah, spread the love. Spread it around. Yeah.
There's Cypher 2 back again.
What? What'd you say? What did you say?
Cypher 2's back since he posted the first chat message How long ago?
Oh, Cypher. Yeah, hey, he's here.
Yeah, he's back.
He's lurking in the background.
Is it
he's in the background. They're all in the background. Many of them in the background.
And hello, Tom K.
Oh, hey, there's Tom K. Open to the simulation theory, huh?
Okay, very rarely.
Well, there's a lot of people that are having, pandemic paranoia and quarantine madness.
Oh my Lord. That is the understatement of the year.
Yeah, you think?
Holy moly. Yeah. I mean, if you thought conspiracies were crazy 2 or 3 years ago, Flat Earth ain't got nothing on 2020. I'm going to tell you that now.
No.
Holy crap. I can't even keep up anymore.
Yeah, heaven forbid it's actually just an ordinary virus that got out of control.
Not even with the virus, with everything else.
Well, there's that.
Oh, yeah. Whatever.
Exactly.
I guess. I mean, you put enough people at home, and they have to. The minds wander no matter what you do.
Yeah.
Even when you meditate, if you meditation, your mind wanders. That's what it does. Your mind, and some people just take it a little too far. That's all.
Yeah, that's for sure.
Convince themselves of stuff. And,
right. So how long was it before you got out of jail, Keith?
About 6 months.
No,
Why?
Hey there, Bobby Burgess. Yeah, that's good. See, what's really cool is on the stream, Keith, and you know what, and I do this when Keith's on because it embarrasses him, but then again, it's okay. The reason that SkyTour LiveStream exists actually is because of Keith. Keith is the guy that pushed me, along with Paul, to stream.
And Bill.
And Bill, yeah, I was coming to that. Bill pushed me to get a radio show and put the bug in the KGRA radio station's ear that hey, you need this guy in your radio. And then they talked to me and convinced me to do a 1-hour show, and then I said, well, I don't want to be talking for an hour to people and just me. And that's when Amanda said that she would love to co-host. I was like, that is such a great idea. So SkyTour Radio has become Amanda and me, and now Daryl is on there with us, and so it's become Amanda, Daryl, and I. Same with SkyTour LiveStream. SkyTour Radio was the Sunday night 8 to 10 show on kgraradio.com. And if I'm in the process of getting the actual numbers, but it looks like we reach about just under 3 million people a month if you look at the numbers on Spreaker and TalkStream Live and the others, and that's really cool. I know it got us the attention of some very high-end people that have contacted me, but
our little baby boy's all grown up.
Yeah, and don't worry, I won't forget you, Daddy. Can I borrow the car?
Sure.
All right.
It's a tow.
Great, because I don't have one. Yeah. No, so of course that's all good, and so we're doing our best to grow the radio show.
Oh, what a feat that is! You take you. Okay. Now, yes, you were the lead photo analyst, or still are, I believe, of MUFON.
Yes.
So you had some connection to that community, but think about how weird that is that you take a scientific program and you put it on a paranormal network, and it gets the listenership that it does. That's quite amazing.
Yeah, it shows me that people want to learn science,
I think it shows that people want to know the other side, because you can hear people spout all day about UFOs and stuff, but they want to hear some of what the other side is saying without being derogatory to the UFO side. You know what I mean?
That's true. But think about this. The book I wrote is about blending science with ufology, in a sense, because I talk about the prospect of extraterrestrial life based on the statistics of looking at the universe from an astronomer's point of view. I'm an astronomer. This is what we look like. Okay, but the thing is,
can I author your author's page on Amazon? Can I write that?
I don't know.
No.
I don't know if you can.
I'll write it and then I'll send it to you and you tell me what you think.
Okay. Knowing you, I'll probably take off whatever I got on Amazon and throw it up there because it's probably gonna be great.
No, I'll make it really good.
I would love it. You heard him tell me that, folks. He's gonna do the author's page. I wrote something, but little tiny bio thing, but whatever.
It's gonna put Mark is a good author.
It's spelled AOTHLE or author.
Or it's spelled Arthur. Mark is a great Arthur.
And he's a great writer.
And he has a great sidekick in Amander.
Well, no, that's what Bill calls her, Amander.
Does Daryl have a nickname that some people call him that they're not supposed to?
No, they just
affiliation or anything.
No, they just call him Daryl.
Okay, so it's Mark and Amander.
I call him D, just for short,
right.
Because when I try to dictate his name into my phone or whatever to leave him a message, it spells it wrong, and I'd rather show him the respect of being able to say his name right, and the phone doesn't believe in respect apparently, so I just say D instead of Daryl, because it's Darrell and not Daryl, which my phone seems to be stuck on, and I've corrected it multiple times, but it doesn't listen. It's evil.
My phone was always correcting one of the words. I forget what it was though, but for years, and finally, I guess it learned and finally got used to me like saying that word.
Yeah.
So it finally corrected, and now it's
I noticed that sometimes it does do that. That's right.
Yeah, it was because on like you have an iPhone or Samsung?
I have an iPhone.
Okay, I have a Samsung, and they like if you type a word and you know it's correct, you can hit a little check mark.
Oh, see, I wish I had that.
Yes, that's the word you were trying to type. Yeah. But and I guess eventually, because I hit that thing like 500 times, and I guess finally realized, okay, this is what he's trying to say. But I don't know.
Yeah. See, you and I talked about this the other, in a couple of streams. Look at the difference in the lava here on the moon and there, and people think the moon's gray. This doesn't look gray, does it? These are very different colors. There's orange soil on the moon. In fact, let me see if it's there's some down here that's actually really, really beautifully visible, along with Tycho. Look at the drama on Tycho right now.
Tycho Brahe.
Tycho Brahe, yeah. The crater Tycho it's just coming out and it's just getting the sun on it. Look at that. Gosh, that's beautiful. And we always when we look at these craters, we look at Tycho and see like this. It's got this central peak in it, and this central peak is that
moon base.
Huh?
Moon base.
Yeah. Oh God, this guy. No, the central peak is what we called it. I called it yesterday on the stream. I called it the bloop. When the first crater is made, boom, all that stuff is pushed out, and then it comes sloshing back in because of the impact, the vibration, and the shock, and the melting, the moon for a very, very short amount of time, that area where the impact happened it acts like liquid. And it's a liquefaction process which causes it to actually flow like water in a sense. And all this stuff comes back in, hits the center, piles up, and then of course it stays like that forever and ever for billions of years. And that's the central peak. But you can call it a bloop if you like. It's the bloop, yeah, the bloop or the it's the bloop. If anyone wants to learn how to do that bloop sound, I'll teach you. You click, you hit your cheek with the fingers like this, and you go wah like that.
And I'll teach you for $5.99 on Patreon.
And if you act now, you get a free Slim Whitman's Greatest Hits. Yeah. So yeah, that's Tycho. And
hello, Para and Cindy and Squatched in Alabama and anybody else we missed? Running up, Bobby Burgess.
Yeah, Bobby. I said hi to him. Cindy Murphy. Hello. She's here now again. That's good.
Daisy and Zoe.
Yeah, and they're gonna call Lane too. Yeah. Come on, we want to see Lane. Let's go. Lane's
are these
cool.
shots? Yeah, they're still shots of the moon.
These are the still shots right now. Yeah, but I'm just checking out some of the colors in the moon too, because when we look at the moon, it's just stunning. And I said it yesterday. The moon is the astronomer's worst nightmare, right? But the moon. Yeah. The moon is also a tremendous learning playground. How do you explain these different colors of the lava?
I still say the moon should be our proving ground
for
extended travel to, like, say, Mars.
Oh yeah. No, I totally agree with that. We're on the same page with that. You know, the moon is not a it shouldn't be bypassed because it's hard enough to get there, and because of Mars' distance, it's harder to get to Mars because on the moon you don't have to worry about an atmosphere. Okay, when you're landing on the moon. On Mars, you do. It's very thin, but it's enough that you will need to engage braking thrusters and make sure those are going to work. Because if they don't, you'll tumble helplessly and burn up in the atmosphere. Unlike on the moon, you'll just tumble and scream until you hit the moon, and then you're silent.
And then you ricochet, and out towards Jupiter you go.
Yeah. Oh, you know what I found? That you guys, all of you listening, will be interested in this. I started looking on the moon because, you know, when the Apollo astronauts discarded the lunar modules, when the lunar module left the moon, only that upper part went up and the descent stage remained behind. So the upper part went up. All right. It docked with the command module up in the lunar orbit, and then they let go of the lunar module. Where'd it go? Well, it went into a decaying orbit and finally crashed on the moon at very, very low angles. Well, I found some of those crash sites, and you can see debris scattered all for miles on the moon, all in one direction. You know, so and those are you can't see them in a telescope like mine or even Keith's, but you can see them on the Lunar Reconnaissance Orbiter Quick Map, which is a free way to look at the moon, and it's stunning. My gosh, you cannot get enough of it. You know, when you look at it, it's just so incredible.
You can even orbit on the LRO Quick Map if you want to. You can pick an area and just kind of orbit around it if you want.
Yes, you can. In fact, and it's really just a beautiful location.
Many hours have been lost in quarantine to the LRO Quick Map.
Yeah, and if you want to learn about the moon, that's the place to do it. You know, so let me. I know that this is a lunar. It's a lunar stream, but I want to actually show. I want to show you guys something anyway. Let me see if I can grab this. Okay, hold on. We're dark only for a moment. I'm going to add another view here.
Is Neowise still up?
Oh yeah.
Night sky, is it?
It is, but I got clouds on that side. I can't look at it tonight.
Ooh.
Which stinks because I'd like to.
Yep.
Okay, so here is the Lunar Reconnaissance Orbiter Quick Map. All right, and let me just adjust here a little bit, just to get rid of the stuff that gets in the way that you want to see. All right, and then we can actually start looking at some neat stuff here, and to this really cool jazz. So this is the Quick Map. Now, it's available. If you look up LROC Quick Map, all one word, you'll get here. All right, I'm not trying to hide anything, okay? But look at this. You can zoom in and zoom in and zoom in, and it just gets better and better and better, and the data gets better and better and better until finally you start getting the individual frames. All right.
We're talking about resolution here, people.
Oh yeah, right now, if you want to know about resolution, you look down the bottom, 6.79 meters per pixel. So about 20 feet per pixel. And it gets better than that. It goes down to half a meter per pixel.
The actual high definition pictures
You're looking
from Lunar Reconnaissance Orbiter.
That's right. This guy right here, this thing right here is probably about 10 to 12 feet across. All right. And, you know, it has so many options. Now, that's how you can do this on the moon. Now, not every spot is covered like that. But, you know what I think, you know, like I was showing you guys.
The first thing I did was went to Aristarchus.
You know what? That's a very good idea. So why don't we do that? Let's just
not the actual crater, but I wanted to see the tubes and what. Yeah, look at that.
Yeah. This is the Cobra Head here. It's called.
Mm-hmm.
And if you know, and see, it's sort of near the limb of the moon. And you say, well, what would it look like if you're looking down on top of it? No problem, because over here you got a bunch of options. One of them is this option, which is a projection option, and we can say, hey, let's go to the lunar globe, right? And now we get to the lunar globe. And I'm waiting for it to come in. There we go. And now, ta-da! And now what are we? Well, now we can look around the moon. We don't have to stay on the near side. We can go all the way to the far side as well. We can look at the Aitken Basin. We can look at the lowest spot on the moon. We can find the highest spot on the moon, which is also on the far side of the moon. Okay, we can look at Aristarchus like never before. We can just zoom right down on top of it like this.
Oh yeah, zoom right into the center peak there.
Oh, and do better than that, right? Because we come right in here.
You can see individual boulders on the center peak.
That's correct. As they replace the look at that. And now, another thing we can do is we can actually we can do things like this. We can orbit Aristarchus. All right, and here we go. And it'll automatically orbit us, or we can move it around, right, and see it from way down low or up high. Now see this? This takes all the wind out of the sails of the lunar conspiracy, folks, because you just can't you can't support your theories and conspiracies when you got this availability.
Yeah, Dole says, where are the first footprints? So you can take them to Apollo 11, and you can actually show them the footprints in the shadow of the flag.
In fact, so what we do is we can go back to our let's go to the orthographic near side. Okay.
And you can actually see how small the lunar stuff is compared to the size of the moon, which is why we can't see it through normal Earth-based telescopes.
That's right.
Watch how far he has to zoom in just to see it.
Okay, so right here, this is Apollo 15, isn't it? Right down here.
No,
I think so. I'm trying to find it manually because it's just to show you how hard it is. All right, and you got to come down way more than this to see. Now we're at a resolution of 0.73 meters per pixel, and so what I'd have to do is I'd have to go and pick the layers and do overlays. Just before I do that, look at all the things you can show. You've got so many experimental results. You can look at the mineral content of the moon. You can look at photos of the moon.
Is it just me, or is your microphone? Was his microphone breaking up for everybody, or is it just me?
It's breaking up?
Yeah, it was breaking up, but now it's not.
Why? I wonder.
I think because you were zooming, and I think it was taxing the.
Oh, I wasn't having any problems.
Just the TIFF images and stuff.
Okay, well.
It just happens when you're zooming and backing out.
Okay, well, that's good to know.
Yep.
All right, so here we have, if we want to filter by emission, you type in, okay, let's look at Apollo 15. We filter by Apollo 15, right? And now, if we tell it to look for Apollo 15, right, we back out until we see a mark, and there you go. Now we have all of the mission critical locations on the Apollo 15 mission. Mostly, if you notice, we're now in at 0.5 meter per pixel. Okay, look at this. That's the rover tracks from the rover. See that? And if you don't like these dots getting in the way, well, then you can just go over here and reduce their brightness to nothing. Here is the lunar descent module, and there's the shadow of the descent module. This is the rover out here, I think. And then we have all the instrument, the all-set packages over here. We got other packages over there. And now you actually see what the astronauts did and where they drove on Apollo 15. Isn't that crazy? There it is. And if you want to also go and look, say, at where the very first moon landing was, let's go look to Apollo 11. So now we'll back out and we'll check out. Let me just go set the opacity to.
Thank you, Tom K.
Hey, thanks, Tom K. That's great. Thank you very much. All right, so now if we back out of here, okay. Now, first of all, see this rill here that we're looking at. Okay, that rill is actually a really interesting location because if you notice, it's in this area of the moon. This is right near Mare Imbrium. This is the Mare Imbrium right here. There's Plato craters 60 miles across. Here is an ancient crater that was filled in, and the lava overflowed the rim at this side. Really cool. And now, if you notice, we have to zoom in really far to see this rill right here, and we go way farther to see the actual Apollo 15 gear on the moon at that location, right? So now I've told it to set up Apollo 11 over in Mare Tranquillitatis, Sea of Tranquility. And right here is where Apollo 11 is. And you'll notice a huge difference to Apollo 11 versus the other Apollos. First, let's get rid of this. Get rid of the opacity so we can see. There's the descent stage right there. Okay? And there's the experimental packages. And that's it. That's as far as they got from the lunar module. As missions increased, they got, a couple of kilometers away from the lunar module once they had a rover. So you see, it's all there to see, but look how far out you are. And this is 18 meters per pixel at this point. And when you go to P&K, they zoom in to about here to maybe, 55 to, 100 meters per pixel. You guys don't get too much. We
did the math one time, and it was kind of like we were 12,000 miles from the surface, 12 to 15,000. So,
Tom Cam, thank you for that comment too. I like that. You've never been mooned like this before. That's great. And meanwhile, speaking of the moon, over on our live view here, let me bring us to the live view. You can see that our moon is still there.
Mark, I'll be right back. I'm going to go grab some Starburst.
Okay. Starburst fruit juice. There you are. Okay. Hey, Axie, how you doing? And Rascally Rabbit, nice to see you. Dalai. Tom K, of course. And Ronald is here. Hey, Ron. And Tara, hello. I was just talking about you, Tara, earlier. Let's see. I want to make sure I bring the moon up in here. We're going back and forth to you guys tonight between the actual moon itself and then the tools that you can use to actually explore the moon on your own, especially when it's cloudy. Okay, and that tool that we were talking about is this one here. This is called the LRO Quick Map browser, and it allows you to look everywhere on the moon at all the locations and sites. You can look at the moon like we see it in the telescope, or you can come up and pick on one of like this selection way up here in the corner and say Lunar Globe 3D, which is really kind of cool because now you can zoom in, but you can also rotate the globe around and go to the far side, and that's cool.
Jackson Crater.
Yeah, you want to see Jackson, don't you?
It's Tycho's twin. You always got to look at it when you have the LRO up.
Yeah. So here's something interesting for you guys to notice. Okay.
Hello, Rascally Rabbit.
Who's here? Oh, Rascally.
Rascally Rabbit.
Yeah. I said hi.
I know. I'm just saying hi too. I am here, Mark.
You weren't just now.
I know. That's why I had to come back. Continue.
Yeah, on this side, this is the side that's facing us, right? Look at all the gray, the dark gray. Interesting, because that shows you that a lot of lava made it to the surface from underneath during impacts. Okay, where? Like right here. When this impact occurred, lava flooded this basin. When this impact occurred, all right, up here, the Imbrium impact over here, lava flooded this basin too. Same as the bottom of Plato crater, and this particular edge here. These montes here, these mountains, would have had a crater name should the rest of the crater have been there, but it's been long since degraded by other impacts. But you see, this side of the moon is really unique compared to the other side. This is the far side, the side we don't see. Where's all the Maria? Where's all these seas, these dark areas? We have one here. This is Mare Moscoviense. All right, and of course we have Tsiolkovsky crater also, which is actually down here, and that's the only area on the far side that has any appreciable dark seas. So when we studied the moon as astronomers, we discovered that the far side of the moon actually is thicker than the front side of the moon. The far side is much thicker, and that means the moon is actually oblate. It's an oblate spheroid. It's not round. It's actually kind of elongated toward the far side, meaning that most of the mass of the moon is through the center of the moon and beyond the center, as compared to from our point of view. It's just past the halfway point, and most of it's on this side. So it makes for a really weird, characteristic of the moon, that it has a thicker crust on the far side than the near side. And the theories that were put forth to talk about why that happened have to do with the fact that in the early days when the moon was being bombarded in what we call the early bombardment phase, there were asteroids and meteors striking the moon from all different directions and hitting the Earth as well. Earth was a molten planet at that point, as was the moon. But as they cooled over millions of years, impacts that would blow material off the moon, and it would go up into the area around the moon. But the moon was also subject to the force of the infrared energy of the molten Earth pushing against the moon. And when stuff would go up into the area around the moon, the molten Earth and its infrared energy would push that stuff across the horizon around the limb of the moon and deposit it on this side. That would mean that over billions of years, over a couple million, actually several hundred million years, this side of the moon would become thicker than this side of the moon. So that's why this side doesn't have any Maria, and we think that it's because the material here used to be here, and it was blown past the lunar horizons all around by the infrared force of the infrared energy coming from the once molten Earth. I think that's just a cool theory, and I kind of like it. I mean, there really is no other way to explain why. And of course, this side of the moon is always facing us, not because it's hollow, not because it's a spacecraft, not because it's an engineered object made by aliens. You don't have to account and use any of those ideas and bring those into play to find out why the moon looks the way it does and why it acts this way.
Oh, you're telling me it wasn't towed into orbit?
It wasn't towed into orbit.
Oh, darn.
Well, as far as we know, as a science guy, I can't say we know for 100% certainty that the moon is not an engineered object. I guess I can't say that with certainty, and that's only because science, suggests that you don't want to be arrogant, and I've always believed that arrogant scientists are the first ones to be disappointed. So, bottom line is that's why that's why the far side of the moon is thicker than this side. And as far as the moon, people say, well, the moon rings, the moon rings. Yeah, but that actually, so does solid rock. And the core of the moon is no longer, it might be molten right near the center, but the rest of the moon is pretty solid now, so that's why it rings. There's a state park right near you, Keith, Ringing Rock State Park. You ever been there?
Sorry, I was enjoying Orange
I
Starburst.
can tell that, yeah.
Yes.
Ringing Rock State Park, and you can go there with a hammer, and you hit the rocks, and they ring. Not as good as a bell, but they ring like bang. And the reason they do that is because they're solid, and the sound waves don't encounter any difficulty getting to the far side, coming back, and setting up what's called a standing wave inside the rock to make it ring in a persistent tone in an amount of time. So that's the thing that happened with the moon. So it doesn't say the moon's hollow, because a hollow object won't ring. A hollow object would sound rather dull, like go funk. All right? It won't actually go bong. And people say, but what about a bell? The reason a bell rings is because it's open at one end. Okay? You make it a solid object, and it'll ring longer. All right? And that is the characteristic that we saw when the moon was ringing from the impacts. And they were seismic rings anyway. That was sound waves that were being transmitted from impacts. And so that's the whole point with this mess I'm trying to explain here. The other thing, too, is if we go back to the orthographic near side now, we look at our moon, and we look at these ray structures. I talked about Messier before, which is the crater that has that really long, extensive ray system. And Messier, where'd it go? I thought it was right here. Isn't it right here? Where's Messier?
You lost it.
I lost Messier. Come on. No, here it is. Duh. All right, yeah. Here's Messier right here. And when we look at Messier, I just had it. What's going on with my head here? All right, what's wrong with my mind here?
I don't know, but Starburst is the best candy ever made.
Oh, see, and here's why. Yes, it is. Yeah, here's Messier right here, and you'll see Messier is a really cool crater. And I think I showed people this yesterday, but here it is. I actually made a 3D print of Messier, and it really, really, really came out beautiful. And I used the USGS data from the moon.
And I've seen it. It does look very good.
Really, it's really pretty. And the moon is actually, and Messier are actually all the data from the moon. In fact, that is here. We actually have all of this data from the moon, and it's in really, really high definition, and it's free to download, and you can get an account. And I work with the USGS guys to try and help them troubleshoot their server. And I actually have all the lunar craters on the moon, and they didn't have certain ones at one point, and I was able to find data sets thanks to some of the guys there that cover all the moon, and it's really good high def data. But I'll give you an idea. So there's Messier there. If we come back here for a second, let me just bring this up now. Hey, the moon's still there. All right, so here is that crater. There is Messier right there, and you can see it has the ray structure and everything, just like we see over. I
feel the need to remind people that they can actually buy these 3D prints too if you want one. Mark has given me tons of them over the years. And you definitely, if you want any specific moon crater, like one that happens to be your favorite, whatever, you can actually get it. He can 3D print it out for you.
Yeah, this one, we actually have a new 3D printer now. And I'm going to, I know that it's annoying for some people. I keep the background transparent so that I can point out things to make it easy. But sometimes if I'm trying to show you something, I just have to do this. This is my office here. And now I'm in a battleship. You see my portholes up here, rivets in the walls, and all that. Yeah, okay. So now it's a battleship. So you give me my secret. So here's Messier. All right, you can look at the quality of that thing. You put it in the light, and you turn it in the light, and you can see all the detail. Of course, I paint these by hand, but then again, I'm an astronomer, so I know where these things go. I know where the shadows go. I know what the colors should be, and all that. And then, of course, if we're talking about down below Tycho, let's go check that out. I don't know if our favorite crater is visible yet. It might not be.
What the heck just happened?
What?
Like the view on Skype went just totally stopped. And all audio stopped and everything. I don't know if you heard me going, no.
No, I didn't.
Everything just stopped, and all of a sudden it came back on. And now on Skype, your mouth is not lined up with the audio. It's weird.
Oh, that's cool.
But it's okay on YouTube. I'm looking at it on YouTube, and it seems like it's fine.
Oh,
so yeah, chalk one up for Skype, I guess.
All right. Well, here's what I'll do for you. I'm going to start sharing again. Actually, but before I do that. It's only because Keith is a complainer, guys, and I gotta just keep him happy, or else he'll never hear the end of it.
Don't make me smack an astronomer.
I'm kidding, of course.
I know.
So we'll do this guy. And
here's the thing: you just put it back on, and still the audio comes through before. Let's see.
Hi there, I am talking.
Yeah, the audio comes through a split second before the video does so, but that's no big deal. I mean, as long as it's okay on the YouTube end.
Yeah, okay. Now, we can't see this crater yet on the moon because we don't, I think the sun's just coming up on Clavius. Isn't it?
Not for, well.
It's right about.
Let's see, we're at 8 days now.
Yeah, 8.3.
So 9. So yeah, in the next, tomorrow you'll start seeing it.
Yeah. I mean, we can see the edge. Because Clavius is like right here, isn't it?
Yeah, it's down in
there.
What we call the wolf pack.
The wolf pack, right?
Because there's a bunch of craters. Everybody
very
likes
cool craters down there. Yeah,
and
so
people are often surprised when they see our streams, and then they go on and they try to look for themselves, and so that they don't realize that Paul usually has them. He tries to vert them, so they're in view horizontally, with the lit side of the moon up.
Yeah,
that way
right.
you can get more of the moon in frame and everything. Yeah. So they have trouble finding it. But yes, all the good craters that we usually look at are on the south side of the moon.
That's right, the Lunar Highlands. Yeah. So we're talking about down in here is where Clavius is. But if you want to know what Clavius looks like, then here it is. This is the 3D print of Clavius.
Come on, everybody knows what Clavius looks like.
See, there it is.
It's that walk down of the craters from biggest to smallest in a nice little arc.
Yeah, see that arc of 3 in the middle there, and that big one on the bottom. And yeah, so this is the crater Clavius. And the nice thing is you can actually take the light and make the light move through a whole lunar cycle and just watch the craters form. Watch the shadows form in the same way that they do in the real crater. It's just really very cool. And it's a wonderful learning experience too. I think that people that are visually handicapped could feel the craters and actually feel the texture of the different depths of the craters, because they're all different. The craters have all different depths. That's another myth, that they all have the same depth and they're all flat in the bottom, because they're really not.
Real quick, I just want to say hi to Tara D and Genghis and Ron at ERRT Radio and Dole. Of course, I said it before, but just in case I didn't forget him. And anybody else I'm missing? James Dugan.
Oh, I missed James. I said hi to all those other people already,
Yeah?
Yeah.
Well, good.
That's okay.
Here. I was eating Starburst. Thank you.
Hey, you know what the truth is? The truth is that, when you come on, we have a lot of fun. And, I have fun anyway, so I don't care. I don't care who I'm having fun with. The fun is the fun. And I'm operating the observatory observation camera right now.
We're a little more relaxed on Keith nights.
Well, that's only because Keith,
is more relaxed.
Huh? Well, you're more relaxed. That's correct.
We're laid back.
Yeah, a little more laid back. That's fine.
So uptight.
Nah, there's no uptight here.
We want you to learn, but we want you to be entertained as well.
That's right. But look, if you're gonna have Starburst in the classroom, you bring enough for the whole class?
Well, screw you, teacher.
Yeah, we'll see. Now we don't care about learning anymore, do we?
Hey, I did you the common courtesy of muting the microphone as I snacked like a ancient caveman on these Starbursts.
more like a cave hog, but yeah.
Same difference.
Yes.
And they were delicious, and I ate the whole pack while I was sitting here listening to you, and I don't regret a bit of it.
No, but your teeth sure do.
Oh, they're screaming.
That's okay. So that's good. And so like I said, tonight is really just kind of a lunar night. We're having some fun looking at the moon.
How about we just call it a hangout? We're hanging out tonight, guys.
Yeah, it's a hangout.
Whatever we want to.
Yep.
There's no real point. We're just here. We're doing some astronomy. You guys want to see something? Throw it up in the chat. Let's do it.
Yeah, no real point. There is.
Point. We want to, people to see what they want to see, but
See, this is where we are in the sky. Okay, for those that actually haven't been here before, maybe it's your first time, and to remind those that have been, the layout is this way. We have on the left side over here, we have this first screen here. This is the telescope control section right up here.
For astro virgins.
Right. This is the telescope computer section I get into. This is the focus system. And down here we have the filter wheels. So we're live right now. So right now we're on the filter that has a full pass-through of all the light. So it's like what you see with your eye. Now, if I go ahead to the next wheel, you'll see it come in. Right. This is a narrowband filter. This is the kind of filter, you don't use this on the moon, you use this on things like nebulae and stuff like that. And in a light polluted area, if you had light pollution, the nebula will shine through this like you can't believe on the photo. yet it looks like it should be darker. I mean, but the filter is passing through the light of these specific nebulae. This is a filter. This next one is a wider narrowband filter. Okay, and that one I use most often because it's sort of a good general purpose filter. Thank you, Farva.
Hey, Farva.
Sean Farva's in the house.
We call this the perp skirp.
Yeah. And this is the spectral system filter, but as I've said before, we're replacing the spectral filter with a full-blown spectrometer, which is here in a little drawer down here, and I'm going to implement it. And so we'll be able to look at the objects we're looking at. We'll be able to see the actual spectrum and tell you what things are made of. For instance, we could have looked at
Terry Groff. I'll just throw that in there before you go.
Terry Groff. What?
Terry Groff.
Oh yeah, Terry's a good buddy. I've known him for many years.
And we're loony.
Yeah, we are indeed.
That is true.
Yeah. I did a TV show in Dallas I had to do, and Terry lives in Dallas, so I actually called him and said, "Hey, come on, let's go do this thing together." So I brought him in, and he came over and he basically showed me around Dallas. We went to a great sushi restaurant. It was wonderful.
Nice.
Yeah, he's a very hospitable guy and a very nice person.
It's just like going outside and doing normal stuff.
Huh?
Like, just like restaurants and stuff.
Yeah.
It's like I couldn't be like in Connecticut and say, "Hey, Mark, let's go out to, get some lunch or something like that," because it's like no place. Well, I guess we could get takeout.
Yeah, actually, that's true. I mean, but we're getting there. Connecticut has the lowest number of infections almost of any state in the union.
Yeah.
We're really rock bottom right now.
And Pennsylvania's getting down pretty good too now.
Yeah, that's true.
So, that's good.
Yeah.
Maybe in the future, guys.
Won't be that long. Won't be that long.
Coming in summer 2021, Keith and Mark have lunch.
That's right.
Outside.
Well, you can do outdoor lunch now anyway. There's a lot of restaurants where you can just sit outdoors. Uh-oh. It's a cloud.
Jerk clouds.
Go away. Get away from me. You'll never come back.
So let's see. Your clouds are then coming from, your clouds are coming from the west?
Yeah. That's a good go out. See, that's good. Seeing the moon, you can tell which way you're looking.
Mm-hmm. Well, it's kind of the southwest.
Ronald says he's still closed out there in Minnesota. Ronald, the size of your town, if the
don't even have a
office,
restaurant, Ronald.
Yeah, really. So stop it, man. You don't even have restaurants.
Maybe he's talking about the local fire company's breakfast.
They don't go out for fires anymore because no, we're not going out. COVID.
Living that nice. Oh, you know what? But that's a nice little town, I guess.
Yeah, it's a postage stamp, remember?
Yeah, I mean, just it has to be like a pretty. I mean, I'm pretty sure you know everybody in that town, Ron, right? So, I mean, that's really small, man.
That's a good question.
Doesn't know everybody.
I mean, he walks around the town for his exercise. He goes all the way around the town.
Yeah.
And he stands there with his iPhone, holding it out, and videotaping the entire thing and streaming it.
Probably like looking out the window, going, "Oh, there goes that crazy guy taping himself again."
Ronald, come on, what's going on? Oh, he says we have a cafe, but it's closed.
Oh, so you do have a cafe? Well, that's good.
That's pretty
at least,
good.
They don't even do takeout for you, Ron?
Oh, I'm sure they can. Brandy, what are you drinking? A milkshake? Is that what you're saying? Is that what you're saying? Ice milk? So you got a milkshake? Yeah, she'll tell us.
Andy said they all avoid Ron. I bet you Ron, they bet you he walks around that town, everybody thinks he's the mayor. He has to form his own paparazzi by holding that phone the whole time.
Hey, Ronald is a good guy.
Mm-hmm. Yeah, and I found myself watching him like streaming live on Facebook, and I'm like,
I know.
Boy, this is the life right here.
I know. He walks around, and you know how we talk, we barely let any dead air go by. Ronald can walk for 15 minutes and say nothing.
Oh, yeah, I've messaged him like
walking.
14 messages in a row, never got a response.
Yeah.
Then he just stopped.
Yeah.
I was like, all right, well, I tried.
It's all right.
Gotta love him.
Yeah. But you got to stop the Diet Coke, Ronald. Okay, that
I think he did. I think he really cut down.
Did he? Because I remember
that's what he was saying.
See, Bill Skywatcher hosted a bunch of us at his house for several days, and in that time, I think Ronald drank like 13 2-liter bottles all by himself.
It's insane. Like, I'm bad with tea, but man, Ronald.
Yeah.
My Lord, that Diet Coke was just, I mean.
He was pounding it down.
It's got an IV of it.
I know.
Put it in a drip bag.
Oh, okay. I see, Brandy. I got you. I do it too. I put ice in milk. I actually put ice cubes in milk. It's really, really good to have cold milk. I love that idea. I do it a lot. So yeah, so Ronald is definitely, well, you know.
He's one of a kind.
Yes.
Yeah, and he is walking. I do give him credit because remember I was telling him when we were up at Bill's, I was like, yeah, get out and exercise, and he's been doing great.
Yeah.
Yeah. And I checked in on him. What was that, Ron? A couple months ago, just to make sure he's all okay in the pandemic and stuff, and But yeah, if you guys ever want, I mean, I wish Ron would go onto his radio station and actually tell his story. Because when I got it out of him up at Bill's house, it was a fascinating story about everything this guy's been through and been in life and stuff. It's really interesting, and I wish he would tell it right on the air.
Yeah, it is.
Think about it, Ronnie. It's a very interesting story. Or if you want me to come on there and gild it out of you, I'll be happy to do that too.
Brandy, that's good. Keep me posted, Brandy, if you're up for it. I'll be happy to tell you more if you need to. Ronald lost 20 pounds.
Yeah.
He kept it. Yeah, I've actually, the last time any of you saw me, I was 198 pounds. And I started just drinking water during the day now. And at night, I'll actually eat a meal. And the first 3 days was really tough. But then after that, I started not wanting anything to eat, and even at dinner time I sometimes wouldn't eat right away, and then when I'd eat a little bit, and within 4 weeks I lost 20 pounds. It just melted off. It went away. I don't know where it went, but it hasn't come back.
I lost 45 since March.
Really?
Yeah, I was 280. Now I'm 235.
Wow, that's really
I'm
good.
6'1" too.
Wow.
So
6'1" too. You mean 6'12"?
My goal is 190. If I can get around there, I'll be happy. But that's going to be a while.
Well, I mean,
because I love Starburst.
As he eats Starburst and tea.
No,
that's fine.
I eat a big breakfast, and then I don't eat the rest of the day, and I burn off everything that I had from breakfast, and then I thought it would be hard, like going to bed hungry or something, but I really haven't been hungry, especially with the heat. So it's been working out pretty good, just eating a big breakfast that lasts me all day long, and then water throughout the day, and of course tea. I love it. And Starburst.
Well, mind you, it during the summer months, we actually lose weight easier.
Oh yeah.
Okay? So.
Yeah.
You have to understand that.
Yeah, it's a human history thing too. We like to pack on the weight for the cold.
Yeah, and I'm not
Thanksgiving doesn't help.
No. Thanksgiving does not help. All right, let me try something here.
I'll tell you what though, I am rocking a farmer's tan. Holy moly.
Really?
Well, kind of. Like I in the summertime I leave the sleeves off, but that's it. So like I'm like all like crisp and tan, and then I take my shirt off and I'm just blind myself. Just a reflection.
I can imagine.
It's like, what's the moon again? 13%?
Yeah.
I'm at 65, 67.
Wow. That's
reflective.
Yeah, okay.
Yeah. Take white socks off, it doesn't even look like I have the socks off. But hey, what can you do?
I guess get a tan.
I'm just not one of those walk around barefoot people everywhere,
Yeah, I know. I'm not one of those either. Okay, we're looking here at this.
Daisy and Zoe have a question for you. It says, what is the largest crater on the moon? Was there any effect on Earth after the impact to the moon?
That's a really good question. And I can show you one of the biggest impacts, but not quite yet. I can. I have to show you over here, though. All right. We have to go back to the Albireo Quick Map browser. If we look at some of the biggest impacts. The impact that scoured out this basin right here. This is the Mare Imbrium, the Imbrium Basin. this is one of the bigger impacts on the moon. And if we go to the far side of the moon, and we go kind of down near the South Pole, you'll see this area right here. This is called the Aitken Basin. Actually, the lowest spot on the moon is down here near Apollo crater, which is, you can actually, and that's another thing you can do with this, you can turn on, in the layers, you can turn on nomenclature, and the nomenclature gives you all the crater names. All right, see, there's Apollo crater. Right there, Apollo crater in the middle of the Aitken Basin. And this is the lowest spot on the moon. And as the lowest spot on the moon, there's also a complementary highest spot on the moon. When the Aitken Basin was gouged out, way up here in this region, right? I think that's right there. The highest spot on the moon is right here, and it's caused by the impact that caused the Aitken Basin. It basically shoveled and put shock waves and ripples through the moon, and like a rogue wave, the material just happened to pile a little more. And I think it's right in this. I think it's right in this area. I'm not sure. I can't remember exactly. So you say, well, what would that do to the Earth? Well, the Earth was, of course, very young when this happened. This happened during the probably 3+ billion years ago. This occurred, and so when we consider these impacts, the one that created the Aitken Basin actually left evidence. There's actually a large object deep under the surface that has yet to be identified, but it might be the remnants of the asteroid that struck the moon. But if we go back to the front side, the side that faces us, when the Imbrium Basin impact occurred, and probably when these impact basins were made as well, over here and here and here and here. Okay, this was during that bombardment phase. If we had that many objects hitting the moon, you see, we also had a similar number of objects or more that were hitting the Earth. Now, the moon was a lot closer back then to the Earth, and over time, the moon has been spiraling slowly away from the Earth by about 2 centimeters per year. And as the moon has pulled away from the Earth, our days are getting longer. We used to have very short days comparatively. I think our days used to be about, I think it was 11 hours maybe, then 18 hours, and then 24 hours now, 23 hours, 56 minutes. But so basically, the moon spiraling away causes this what's called a momentum transfer, and the Earth slows down in its rotation rate a little bit at a time. But if you say, well, how long will it be before the moon spirals away from the Earth? Because it will. There is a time. You can calculate that time. But it's going to take longer than the sun has left for it to actually happen. So the moon will never leave the Earth's gravitational influence. And we will never be without the gravitational influence of the moon. All right. So, unfortunately, we're stuck with the moon in our night sky as astronomers. We don't like it, but it's there.
Teasing us.
It does, yes. Okay.
Yeah. It's like, going away.
Right.
Just a little bit of year. Nope, ain't going nowhere.
Just kidding. So the thing is, what would that impact do to the Earth? Well, remember, the moon is really far away. So the impact would have thrown material up into the area around the moon. I can't say up into the air around the moon because it never had air. If I want to be technical about it, I could say it would throw rock and material up into the exosphere as opposed to atmosphere around the moon. So the material that went up into the exosphere around the moon could have gone out to some distance and then come back and hit the moon in other places, creating other additional craters. Or some of it could have been blown off of the moon with such force that it escaped the moon's gravity and possibly spiraled toward the Earth. But keep in mind, the Earth was already mostly molten by then, getting pounded by other materials as well. So as far as the impact on the Earth, what it might have done to us, we were both in a similar state. So it'd be hard to differentiate what happened on Earth versus the moon and who caused what to who, you know.
It was the instigator.
Yeah. The instigator actually is the Earth. And, a lot of people say, well, the moon was so important to developing the life on the Earth. Well, yeah, I mean, when we look at the moon, we know that the moon actually is important to the development of life on the Earth. There's no doubt about it. Okay? But the question is not whether it's important to life on the Earth, but was the moon essential for life on Earth? And I have a different idea about that.
I want to say no.
Yeah, and I think that if you look at your magic 8-ball, shake it up and look, that in the little window you might see my sources say no. Okay? Yeah. I don't think that...
Can I tell you my theory on why?
I would like to hear why you think the moon might not have played... it played a role, for sure. It was very important.
Absolutely. But I think of it on the title thing.
The question
is, of course, the moon's not the only thing pulling on our tidal forces. The sun is also doing it.
That's correct.
I'm thinking just for tidal reasons, and I'm going to say Earth's heat probably too is not going to be that much affected by the moon pulling underground magma. But yeah, I'm going to say with the tidal, because we have the sun when it comes to gravity anyway. But what do you think?
Well, okay, I'll ask you a question. Okay, we know the moon is much closer to us than the sun.
Sure.
But what magnitude of tidal forces compared to the moon does the sun have? Do you know that?
Comparison
like how strong is the sun's gravitational forces on the Earth, tidal forces on the Earth versus the moon's?
I'd still say they'd be pretty significant.
That is correct. They are.
Yeah.
The sun is massive.
Be more.
No, it's not more than the moon because the moon's proximity. However, we would still, if we had, let's go to the Bay of Fundy, up in Nova Scotia. Is that where it is? Bay of Fundy. It has the huge tide. It has a very huge tidal difference. At low tide, the tide could be out down to, another like 30 feet lower than when the tide comes in. And that's really odd. You might lose 6 to 8 feet up in Maine, but up there in the Bay of Fundy, because of the geography and the layout of the depths of the bay, you can drop 30 feet. So the question is, if the moon disappeared tomorrow, how deep or how far out would the tides go? They wouldn't drop 30 feet, but how deep would they drop? The answer is they would drop about 15 feet. So, in other words, we have about half the tidal force that we have on the moon. The sun is much farther away, but it's far more massive, so its gravitational force affects us by about half as much as the moon. And what does that mean? It means that we'll have tides. We'll still have tides. We won't have spring tides and neap tides. We won't have tides where the forces add to each other to make extra large high tides and extra small low tides or whatever. But
that happens when?
Huh?
Buddy in the chat?
Okay.
Large high tides? It's when they're on the same side? No? Okay.
Yes, when the forces add together to make a deeper, tide, yeah.
Yeah.
So the question becomes, when you look at the
hello, DW. See you in the chat there.
Yeah, he's here now. He was here before too. All right, so
go ahead.
No. So yes, when you always mean to interrupt me, who are you kidding?
Yeah,
that's fine. So the sun's tides will still allow for tidal flats. That is to say, tide pools, where fish that are going to transition eventually to being air breathers can still be without water covering them for a period of time. What's that?
Big dumb fish being mouth breathers.
That's right. and that air breathing transition is what led to the creatures staying out of the water longer and longer and longer until they could stay out of the water the whole time and just go back to, wet their skin and so forth. The problem,
eggs. They had to go back to lay eggs for a long period of time as well.
Yeah, that's right. To reproduce, they also had to do that. And I think I think that a good question, Brandy. We'll see if we can get to that in a bit.
It's gonna be a topic.
It will. Um, the the fish that ended up sitting outside of the water and just hanging there. This took a
Was
long
it a
time.
mudsucker?
Yeah, right. It took a long time. It took a transition. Took not 10 years, not 100 years, but thousands of years, maybe more, maybe a million years of time, over time, maybe hundreds of thousands of years before they evolved to stay longer and longer out of the water. That process is sort of systemic to evolution. It takes a long time for things to happen in evolution because evolution, by definition, is mutation followed by adaptation. So something mutates, and if that mutation favors the survival of the organism, then the next organism, that organism will survive to reproduce and have more of the same kind. If it doesn't favor it, then it may not survive to reproduce. So this happens quite a lot, in evolution. And by the way, just because we know about evolution doesn't mean it isn't happening anymore. It's happening right before our eyes.
Oh yeah. Think about bacteria, people.
Yeah, it's happening right before our eyes. Actually, COVID mutated a dozen or more times so far. And so the vaccines are only good for certain mutations. Beyond that, they don't work anymore. Back when we had the swine flu epidemic, and back then it was called an epidemic, swine flu just vanished at one point. Suddenly it was gone. What had happened was it mutated away from being a lethal strain, kind of like the Andromeda strain. Remember the Andromeda strain? The movie where it turned everybody's blood to powder, and rubber just disintegrated. I mean, I was so scared by that movie. And then I was, because that scared the crap out of me. And then some years later, wouldn't you know it, I end up meeting and becoming very good friends with the man who made the movie, Douglas Trumbull. He actually bankrolled that movie, and he took Michael Crichton's book and turned it into this major motion picture.
I often thought about let's say if we let a virus or a bacteria run its course.
Yeah.
I wonder how long it would take for us to be like old mudsucker, to evolve a natural defense to it. Would it take, because you see how bacteria now is becoming antibiotic resistant and stuff like that, and it's actually a pretty fast process.
Yeah.
So I'm wondering how fast the human body would adapt to make up its own defenses against a heavy duty where antibacteria wouldn't work.
Yeah.
How long do you think that would take? Would it be years? Would it be decades? Would it be weeks? I'm guessing. I often wondered how long it would actually take for the human body to just put up defenses of its own, if it could. Now, obviously, people are going to die. We got that. But I'm just saying, for somebody to actually build up natural defenses, I wonder how long it would be.
I can't really answer that question because I don't know. Because I know that there's varying degrees. Huh?
I wasn't expecting you to answer it. I'm just saying if you ever thought about it.
Okay. I have thought about it, but again, not being able to answer it's fine because it is interesting because we have noticed that within a few generations, some animals will develop an immunity to something. Some animals will develop resistance to antibiotics. So some creatures,
right.
We know that happens. So
not only that, but I just read not too long ago that some babies that have been born recently have a natural immunity to smallpox. I don't know if that's from just the little group that they tested, or whether it's because of the vaccination back in whenever it started, and all of a sudden it got written into the genetic code somehow.
I think that's
very interesting.
Yeah, that's actually very interesting because I'd want to know. That's actually a very cool thing.
I know, and I just thought it was fascinating that, okay, so let's just say we find a vaccination for this coronavirus, this COVID-19, and let's say 4 generations from now, they test the blood or whatever of one of our people down the line, and all of a sudden they have a natural immunity to it? Is it because of the fact that we vaccinated and then the DNA just wrote it into the genetic code of reproduction? Or, it'll be amazing to see if we can actually get a case study for that.
Sure, that would be wonderful. I think that'd be a really cool thing to try.
Yeah.
Yeah. By the way, just so you know, the Apollo 15 landing site that we looked at earlier is right here, right there. So it's inside this special little valley, and the rill is in here. It's really hard to see the rill tonight, but again, we have a lot of moisture in the air, and it's not very good seeing tonight, and the transparency is not very good, so we're not able to see things quite as clear as we could. There's been some wonderful nights where we have beautiful seeing and transparency.
This music is crazy. What the heck?
What?
The Lion of the Mountain.
Oh, the Hall of the Mountain King? Oh, yeah. Yes. Yes.
I'm like listening to you, and I hear this in the background. I'm like, oh, what's going on?
Yeah, it's like, the Heart of the Mountain King. Yeah. Ba-ba-ba-ba-ba.
Obey me, Hercules.
Yeah.
All of the Mountain King.
Yeah. Sorry, that was just a little too energetic there. Yeah, but that's where Apollo 15 landed. And you can see, based on what we did, we zoomed in so far in there to be able to see the place that the Apollo sat down there. And you can see we can't possibly do that.
See you later, James.
James Dugan's leaving?
Yeah, he's got a 100-kilometer drive.
Oh, that's okay. That's a 60-mile drive. Yeah. So, anyway, I appreciate that people are here tonight to check things out. I find that we're having a beautiful night just checking out the moon. It's having a ball here. And let's see now. Do we have what else do we want to look at?
Yeah, anybody got anything in chat do you want us to take a peek at? Huh? Anybody? Nothing?
Well, this is where we are right now, actually. So if you look at this view, this is actually a view of the observatory location.
Hey, man.
See, I made this whole...
Go to Jupiter.
Huh?
Go to Jupiter.
You could.
That's why I
could
told
do
you
that.
to.
What'd you say?
I said that's why I told you to.
Oh.
Because I know what's there.
We got Jupiter and Saturn,
it might
too.
be a cloud. Well, you said the clouds were coming from the west, right?
Yeah, I actually disconnected the All-Sky cam because that's getting shipped out to the Arizona site.
Well.
So I have to do that. And then I got to ship the computer out to the Arizona site. And then...
point the telescope at Jupiter.
Okay, we can do that.
Yeah.
So we've had our share of the moon, but we can come back to the moon.
Sure.
They're far enough apart so that it's going to be a little bit of... I'll have to go out and move the dome.
Really?
So, yeah. That's okay. I don't mind. As long as you don't mind. I don't mind moving the dome because we have to do it.
It's all part of the job.
It's all part of the job. Mm-hmm. That's right. Mm-hmm. It's all part of the job. And we'll take care of that for you, lady, right after this.
There you go.
Yeah. All right. So I will head out and move the dome. I shall be back.
We're going to look at Saturn and Jupiter.
Yeah, actually.
As long as they're in view.
Yeah, let me check that too, because I can't check the clouds at the moment. But I will go out and check it, and I'll let you know in a minute. Be right back.
Sure, she explained a little bit earlier
how
many
meters.
meters.
You got to take on everybody now. You got to make sure that they all have all their questions answered by the time I get back.
Okay, not a problem.
What's that? I'll be back.
Not a problem. I got it handled. Not a problem. What the hell is this guy talking about? Anybody follow that for the last hour? Anybody? Okay, good. I'm not the only one. Yeah, Doug, I know your first name. Of course I do. Anyway, Trish, Mark did say earlier when we were looking at the LRO how many meters per that he could see. I forget what it was though. Mm-hmm. Oh my god, this music's driving me crazy. It's like right in the headphones. Every time I stop talking, it comes back on. It's very, very tinkly. It's making me want to pee. Oh wait, has a beat. By the way, you can see SkyTour Radio, KGRA Radio, Sunday nights 8 to 10. You can see Mark up on NASA's Unexplained Files and What on Earth and Aliens on the Moon. And you can also follow some of his work on MUFON if you want to, because he is the lead video and photo analyst for MUFON. Besides that, you can see him here on the SkyTour LiveStream, live on YouTube, whenever he hits the broadcast button. Then you get nice tinkly music like this. And you can usually find me over at P&K Space Imaging or sitting in a corner crying myself to sleep.
And?
Nothing. Sitting here just talking to people.
All right.
How are you doing?
Just fine, just fine. We're going to go to Jupiter and then Saturn.
This music was making me want to pee. It's very tinkly.
Wow. Okay.
It was. It just had like a tinkly sound to it.
Okay.
I don't know how else to explain it. It was like...
Yeah, I don't know. But that's okay.
That's cool.
No, it's fine. Not a problem. Yeah. Let's see here. Let's get this.
Hey, Mark.
Yeah?
Mark.
What?
Sausage.
When Keith says that, he has no idea. He has no idea what you're talking about. That's his go-to word for I don't know what you're talking about.
Well, that's what I like to do when I like to confuse people. Like, especially if they're talking and they're like, you know what I mean? And I just look at them dead square in the eye and just go, sausage.
That's right. Hey there, Toilet Room. How you doing? Good to see you. Thanks for joining us. Trish D, I see you now. I actually, my zooming into the moon is, I can go like, I could zoom into like about here. All right. For instance, this is the Apollo 15 landing site right here. And it's kind of cool, but you know what? There's other ways to see more detail in here, and the night is certainly not conducive to that. It's really, really a turbulent night. I don't think we'll see too much with Jupiter either, but we're going to try it anyway.
We're going to try anyway for Jupiter and Saturn.
Yes, we are. Hey, stick with us and we'll be here for you. So, step one, we go into our screen here. Now, as I mentioned before, I started by telling you this is the telescope control. This is me. Hi. Okay. This is our online planetarium. Actually, it controls the telescope. And we know because we move to the moon, you can see the words scope. This tells you where the telescope is pointing relative to the moon. All right. And we can move this anywhere we want. And right now, we're going to move it over to Jupiter. So we click on Jupiter. And we tell it to go. And what we do when we do that, actually, we come back, and since the telescope is already, the dome is already pointing away from the moon, you can't see the moon anymore. So I've got Jupiter in here, and then I'm going to hit Control to go. And now the telescope is moving. And we should see some stars showing up over here.
Telescope moving across the sky.
Yes. Here it comes.
This stream is brought to you by Ultravitamal. Our new sand smoothies. Tastes like diesel fuel.
You are something else. And what we do is, we don't see anything. We gotta. There we go. That's the star that we're lining up on. Yeah.
Hello, Justin and Jax.
Hi, Jax. Katie Q. Amal, how are you? Nice to see you guys. Telescope lines up on a star first, that it knows where it is, and then from there it goes directly to and calculates the location of the object. It's called high precision slewing, and that's what it's doing right now. And look what we see.
Slewing.
There's Jupiter.
There is Jupes.
Yep. And we see...
a lot of...
Well, we actually see the 4 Galilean satellites right here. Yeah. And if you want to know what they are, then we can actually do this.
So they're not moons like poking out on the right and left?
No, those are moons. Those are the moons.
No, I mean further out.
Oh, those guys? No, I think those are stars.
Further out. Okay.
Yeah, those are the Galilean satellites we're seeing now. All right, so if I take us to Jupiter, all right, and we zoom in, this image shows us what we can expect to see on Jupiter. It's actually an accurate representation of what Jupiter looks like. Okay,
running away from you.
I know, it's because I pulled away from center.
Uh-huh.
Okay. So
hit the second button quick.
Huh?
Nothing.
Oh, yes. So this first one here on the left, this is Io. You can see it over there, Io. And then we have Europa over here, all right? And Europa is this one right here. And now what's out here is either going to be Callisto or Ganymede, and we have to look to see which one. It depends on I think that's probably going to be Callisto, actually. Let's see if I'm right. Yes. So that's Callisto way out there on the right.
Callisto.
Okay? And then right to the right of Callisto, you see there's a star right there. Is that star present? Yes, it is. Okay, there it is. You see it? There's a star right there. That's the star in the chart we're looking at. All right, and on the left, that means this is Ganymede. Hey, Rockstar, thanks, man.
Thanks, Rockstar. Coming at you with $10.
Yeah, you guys are awesome.
Where's Rock been?
He's been here. I see him every night. Actually, we've been in. He comes in.
The dude.
Huh?
I said I hardly see the dude.
Oh, you're hardly streaming, because you don't.
Yeah, that's true.
Yeah, so Ganymede's on this side. Ganymede's interesting. It's like 3,000 miles across. It's almost it's the size of a small planet, actually. It's the largest moon in the whole solar system. It beats Titan by just a little bit. It's a couple hundred miles.
Titan.
Yeah, and Titan is. We'll see Titan shortly too. And now to the left of Ganymede, the reason I'm letting it drift is because then we have this star that you're looking at. That star happens to be right there. Okay, right there. That's the star you're talking about. And here it goes, right there. So you can see that our chart is actually quite good, Now what we'll do is let's go to, well, we're at 1,000. This is the photographic control here, and this is the dome ops.
Let's take her down.
Yeah, this is actually, well, we're not going to do clouds yet. Not bands, cloud bands and zones yet. We will in a short moment. But I want to actually go up and take a picture that's, say, 4 seconds. Let's do 4 seconds at 1,000. All right. Now I want to show you something that it should show. Here we go. All right. Yeah. Okay. We got a little walking there. I gotta fix that. All right. Yeah. I had to see what was going on there. I was just doing a test of the telescope's guider, unbeknownst to you guys, and it wasn't doing what I wanted to do. So I'm now gonna.
Look at that. So you're not exactly focused, huh?
No, it's not. It's not a focus issue. It's a guiding issue.
Oh, that's right. You're doing pictures.
Yeah, and I'm going to.
Sorry, I'm so used to video.
Yeah, I know. Yeah, P&K has the corner on the market for being able to do exceptional crater dives. That's
yeah,
for
if
sure.
we keep it up, we might actually get to Uranus.
Boom. Yeah. Okay. Let me do this. Okay, do that. And okay, hold on.
This music is making me want to have a shot of whiskey.
That's the kind of music it is.
Yeah. It's the old bar long 66.
Yep. And we're going to go up to do 10 seconds. And we'll make this not 1,000, but we're going to go to much higher. What I'm going to do is get the area around Jupiter. Well, 5,000 for 10 seconds. I want to see the area around Jupiter and get an idea of some of the stars that are around the planet at the time. And we compare them, and we come in here, we compare them to here to see what we've got. All right. And so what do we have? That's that star. All right, so we have Jupiter here, and it's centered. Okay, let's go see what we got. All right.
There you go.
There we go. Of course, I still have to fix the other axis for the guider. I did the right ascension, which is the left, right, east, west. All right, so let me go take care of that now. I can do that right now, actually, from here.
Blue ring around the rosy.
That's right. That is correct. You are correct. That's what you got to do.
And then he gazed upon Jupiter, Earth's big brother protector against meteorites and foreign objects.
Without Jupiter, Earth most certainly couldn't have existed. The big brother to the planet swept asteroids and other ne'er-do-wells from the inner solar system, saving the planet and allowing the fragile life to take hold.
Oh my.
Well, that's the truth. That is the truth. Okay. What's really funny and is that that's kind of how I think all the time.
You think in monologues?
I think in strange, not monologue, no. I think of it in terms of that romanticism, because the universe to me has always been beautiful, mysterious, unique. See, I fixed the guider and all. Look at this.
Jupiter went supernova.
Yeah, it's like, yeah, but this is great because now you can see all of the stars that are in the field here too. These are all light years beyond these guys right here. 1, 2, 3, 4, 5. All light years beyond. So I think that's pretty interesting. Now let's do what you would like to do, and let's drop this down. If you want to take pictures that actually show us just Jupiter and how Jupiter looks with its cloud bands, well, we have to lose the moons. You can't
take... This is a mini educational process on exposure.
A mini education, yeah, it's a sort of small exposure, yeah. Exactly. So this will be a fraction of a second, and...
Second.
Yeah. And when you see Jupiter here, actually, let me show you something here. I'll bring it down a little bit.
And I'm going to go get more Starburst while you do this.
Oh, boy, you don't need more sugar, man.
Yummy.
He's like, I need more sugar, I need more sugar. Oh, yeah. All right. Can you imagine his mother? Oh. Danger, Will Robinson. Yeah, so there's Jupiter. And I'm going to drop down the exposure a little bit now. And you'll see how some of it will come clear. I think that we probably want to refocus as well. But I'll take this shot anyway, and then we'll see where we are. All right, so there's Jupiter right there. Yeah, it's not that bad. You can see these bands, okay? And those areas on Jupiter, they're beautiful. Now, when the Juno spacecraft took photos of the poles of Jupiter, we saw these amazing, detailed, and intricate swirls and patterns of blues and browns and reds. Jupiter is mostly hydrogen gas, like the sun. And the concept that Jupiter's a failed star is the wrong way to look at Jupiter. It's not a failed star. It never had a chance to be a star. It would have needed to be 80 times the mass it is now for it to even be a smallest of stars. So,
hello.
So yeah.
Oh my.
Yes, DW. I talked to Marianne twice today, actually. Marianne is doing okay. For those that don't know, and Marianne is okay with me saying this, her husband passed away suddenly a couple of weeks ago. And yeah, you didn't know that, Keith? I'm sorry, I didn't really realize you didn't know.
Oh, I think that's what Amanda was messaging me about, but I didn't know what she was talking about. Like I didn't put two and two together.
No, and his name was Don Robb, and Don, he was a retired firefighter, a decorated fire captain actually, black belt in Taekwondo. I mean, I'm a Taekwondo guy too. And every time I went out there, Don said, "Oh, you stay in the house. Always come here. You always got a home here." The kindest man on the planet. And I was just out there last month, and we had pizza together. And I came home and found out that, not on the flight, but like the day after, that he had died. And that was like,
wow.
So that was very, very difficult.
Well, my condolences to Marianne.
Yeah, no, she's actually, I actually supposed to fly out to the service on the 24th, but because of COVID, I couldn't do it. And so they actually streamed the service, so I watched it all. And of course, Amanda was with us, as was.
Yeah, I think that's what she was messaging me about.
Yeah,
but I didn't put two and two together.
Yeah. And I thought it was interesting. I walked into Marianne and Don's house the first time, and as I walked in, there's animal heads all over the walls, and there's a Taekwondo, practice dummy on mats in the living room, and half the living room is a gym to work out. So talk about a functional living room,
right?
And it was really interesting, and so. And the animal heads were, because both Marianne and Don were avid game hunters. They would go up and hunt. I'm not a hunter. In fact, I always complain. Why do you kill things? You can buy food. You don't have to, kill additional food. But there's a little black squirrel sitting on a fake log that they had. It's like, what'd you kill a little squirrel for? So I always harassed them about that.
I don't hunt only for one reason. I'm afraid that sometime down the line, deer are going to get opposable thumbs.
Yep.
And they'll start shooting back.
Yeah. And that's
way away, but I'd rather say, this guy's ancestor was one of the first.
Yeah, right. It might not be deer. I don't hunt because I'm just kind of against. I can't kill things. I don't kill things. Sure. I live as gently as I can.
Dude, you're talking about a guy here. Like, I will pick up a spider and take it outside.
Oh, me too. Yeah. I think spiders are phenomenal.
Or if they're ugly, I might flush it down the toilet as a mercy kill.
A mercy kill.
Most of the time, I take them outside.
Now, my little friend, your legs are too fuzzy and you're kind of ugly. So what? You get the toilet.
But two things I don't have any love for, and I will kill at sight. Just those Chinese lantern flies that just made their rounds in the last couple years. They're just bad all around.
Chinese, fireflies?
No, lantern flies. They just arrived in this country a couple years ago, and they're starting to, I pulled probably 100,000 off my trees when they were little babies. See, they lay their eggs, and then the next year, the eggs hatch and they fall to the ground, and then they slowly climb the tree. So you got to wrap your trees in this sticky tape, and as they climb the tree, they get stuck on there.
Those are we call those gypsy moths.
They're spotted lantern flies. That's what they are. No, this is a totally different thing.
Okay, but I remember the trees having scars. Having scars for decades because people wrap them in this goo so that when they try to climb the tree, they get stuck in it.
Yeah, these are just tape because the spotted lantern flies are stupid, so they just get on the tape and stick there and die. But yeah, I had to have 100,000 that I caught easily between all 8 of my trees. It's been ridiculous. And
I watch people there are these tent caterpillars. They actually build these tents of silk in the trees, and thousands of caterpillars are in there.
Usually in bushes, right? They're usually in the bushy trees.
In trees, yeah. And then what happened was at night people would go light them on fire to burn them up. Yep. And it's like you realize the whole tree's flammable, right? And most likely they didn't. And the fire department gets called. Another tent caterpillar. Yeah. Oh God. Why don't you guys learn to just use a shovel, move them? Whatever. Just don't Don't light your yard on fire to get rid of things.
Oh yeah, stink bugs too. I forgot about them. I hate them little bastards.
Oh, why? There's nothing wrong with stink. I got actually 2 or 3 of them, and they fly around the house all the time. They're in the house, and they're not hurting anything.
You're a sick creature, Mark.
What? They're
That's okay. No, that's
look
okay.
at the world from their perspective. They're trying to get out.
If they stayed outside, they always try to get in. When the fall comes, it's warmer inside, so they'll come in through any ways possible, and then they terrorize you. Especially when they come flying at you with their big floppy wings, and I scream, and never mind. I don't scream.
The only thing that I can't tolerate is hornets and wasps, yellow jackets. I can't tolerate those because they're just angry all the time. They always have an attitude. You can't make one. You can't make one a pet. Unlike like Monty Python, Eric the alpha bee.
You know what good ones are though? Those carpenter bees. I mean, yeah, they tear up any wood surfaces, but they're really friendly. Those big bubble-looking bees.
I have them sitting out there. They hover better than any other creature I've ever seen. They're beautiful hovering creatures.
They're like the bee-ear blimp.
Yeah, that's right. I had 6 of them. I had 6 of them here, and I tried to figure out where they were because, of course, they're protecting their nest, their property. So I watch where they go, and it's like they make one single hole and they climb up in the hole.
Yep.
What the heck?
It's like, you don't know what I'm doing behind this wood. The next thing you know, it's all tunneled out, and there's condos in there, and
that's right.
There's 1 inch
parties, a lot of music, wild music coming from inside. You hear.
Oh yeah.
All
like,
night
what
long.
are those bees doing?
Yeah, that's right. Yeah.
Break it down.
Yeah, that's right. Bee. This is the bee music. They make bee movies,
They are interesting. I mean, they land on you. You can pet them. They're all furry. Like, they're pretty friendly, but they will attack the wood in your house, and they just like making holes.
Yeah. I don't terrorize them. I don't have any problem with them, but I just.
And bumblebees are great too.
What is?
Bumblebees, little ones you see hopping from flower to flower.
Oh yeah. I don't mind bumblebees. Okay, I'm gonna do a little focus here on Jupiter. Okay, way out of focus now, and bring her down. When you reach the focus, you know where it is. So let me do that. And by the way, to those of you wondering, this is a microphone, a boom mic that I've got right here. I use it for the radio show. You get my professional radio setup for the streams. I guess it makes it easy, right?
Yeah.
Yeah, you do the same thing.
I have professional microphones set up as well.
Yes, you do. Along with the Jupiter 2.
By the way, I should ask, how is my microphone tonight, guys? Am I level with Mark? Am I? Is there enough bass? Am I too trebly? I think it sounds good in my headphones, but you never know until you actually hear it.
I'm looking at the levels, and our levels are almost identical.
That's cool.
Yeah. So, all right. So that looks pretty interesting. So if I drop the exposure a little, see that the night is so lousy, essentially, that we can't we can't get a really good picture of Jupiter tonight. I used to do a. Let me actually bring down the music a bit because it's getting loud. I used to work with a refractor telescope. Now, refractors are the ones that have lenses at the end, and the light is, it's refracted down to a tiny little point where it comes out at the end and goes to your eye in an eyepiece. So if
really good for planets. Just by the way.
Yeah. Refractors are very good to show you planets. And so when I was getting my degree in astronomy, I was also participating in a parallax program where we were studying nearby stars and calculating their distances very accurately by taking photos of the star on the left side of Earth's orbit and the right side of Earth's orbit, and the distance between was 93 million miles to one and 93 million miles to the other, so clearly times 2. And so we had a large baseline, and so when we looked at stars that were nearby, they would shift against further background stars in the same way that you hold out your finger and blink your eyes. Okay, if your left eye is one side of Earth's orbit and the right eye is the other side, you can see how your finger, the nearby star, is shifting against the farther stars of the background wall. And that shift gives you the distance to the star very accurately if you can measure the shift. So the closer the star, the easier it is, okay? And so we had stars out to about 300 light years, and we calculated their distances, and we did that with a 20-inch refractor. That means the lens is 20 inches in diameter, all right? And that's a big refractor.
Big refractor.
And in fact, the tube itself of this 20-inch refractor was probably 45 feet long. And the observatory dome that it was in, it was huge. I mean, it went up probably 60, 70 feet. And the telescope was fully contained within it.
What was that at?
That was in Middletown, Connecticut at Van Vleck Observatory.
Is it still there?
Oh, yeah. Yeah. And they got more telescopes now. I used smaller scopes. And you know what? I've left my mark on all these observatories. I damaged this big refractor.
On it?
No. I damaged the big refractor one night.
Oh.
It was 3 or 4 in the morning. I had the midnight to dawn shift a lot. And it was like February. And it was really, really cold. Hey, here's Amanda. Look at that.
There's Amanda.
Yeah, does she want to come in? Amanda, let me know if you want to come in. And so we had there was a safety rail around the central pit. If you stepped over that and fell down, you'd fall 45 feet or more into a morass of concrete and rebar and stuff in the basement. And it was really, so the safety rail, 2-inch steel poles, on a railing going around the middle. And the reason it was like that was because of the fact that hey Amanda, the floor had to go up and down to meet the telescope. So the whole floor moved up and down with all the controls and all that, went up and down with it. It was really a lot of fun. It was a gigantic elevator. All right. So
hello, Johnny.
Is Johnny here too?
Johnny's here too.
Oh, good. All right. I'm bringing in Amanda. As you folks know, Amanda is the co-host of SkyTour Radio with me, and Daryl joined us as well, and Amanda's now here, and she's also the co-host of SkyTour LiveStream. And so, Amanda, hello.
Hello. Hi, Mark. Hi, Keith. Hello, everybody.
So, I had mentioned that we were streaming tonight, and if Amanda could join us, leave a message in the chat. Because, let me... you see the screens, right, Amanda?
I do.
Yeah. Okay. Good. Okay. So you can see that I can't check Skype from where. I mean, it's down here, but I don't check it. I'm looking at all this other stuff. So, we're trying to look at Jupiter right now. I've just focused a little bit, and the sky is very unsettled.
Looking at a dust speck.
Yeah, it is. It looks like an orb. It's an orb.
It's an orb. It's a ghost.
It's orb. Oh, that's actually not bad. Look at that.
Oh, there you go.
Yeah, we can see detail in there.
Yeah.
Let me actually go to the...
Got some jet streams running on there.
Mm-hmm. Way to do it was you got some jet streams in there. Yep. Mm-hmm. Yeah, that's not bad.
You know what? If you would take the contrast up a little bit, you might be able to get some little more detail.
Like that?
And you probably do that in OBS, though.
I'm doing it.
But, yeah, it's not bad.
Yeah, there's some prettiness to be had.
Purdy.
Yep.
Hello, Amanda.
Hi, Keith. How are you?
Good. How are you doing?
Good. I said hi when I first got here too, didn't I?
I know, but I'm
Okay.
so screwed up I'm not paying attention.
Okay. No worries.
Let me tell you how good Starburst are, though.
That's...
Starburst candy?
Yes.
Yeah.
Sugared up.
I like strawberry.
Oh, yeah, I had that. And then there was, it was the original flavor pack. Oh, it's so good.
So this Amanda's Jupiter with the little bit
the
of
J.
Yeah, with a J. Yeah. It's Jupiter with a little processing. So that's with processing. You can actually see some modeling in the band there. That's really beautiful. Looks really nice. And for a bad night, it's not so bad. In other words, so what I'm getting at.
It's kind of made me wonder about Saturn.
Well, that kind of makes me think we should go look and see if we can see Cassini's division.
Yeah.
I actually saw it the other night quite well.
Oh yeah, we had it on our channel the other night, pretty good too.
Nice.
And it wasn't really good skies either, but for some reason, Saturn likes us. It seems like every time we do Saturn, we get it pretty good.
Yeah. So this will take one shot with the moon, so we can actually show the moons here, and
I see the 4 moons, the 4 Galilean
yes,
moons.
you do. And do you know which
Wow.
ones are which? We went through this already, but I want Amanda to tell us. Amanda remembers astronomy. She is amazing. She is almost an astronomer, I think.
I have. See, now
Start with the
this
easy
isn't
one.
really fair. I know I can tell you them in order, but are my eyes tricking me? How do I actually know the distance?
You don't.
It looks like the one on the right would be the closest, so that would be Io.
Okay, in this case, you are absolutely correct. Ta-da!
Now, again, I don't know because of the distance and brightness and all that kind of stuff, but I'd say the one to the right of that would be Europa.
Ta-da! Correct.
Ding!
I'd say the one on the far left would be, oh my god, Ganymede? No,
Yes, it is. No, you got it.
Okay, why was I thinking that belonged to Saturn? Okay, well then the last one on the far right is Callisto.
She got it right, guys.
Wow.
She got it
See, I
absolutely right.
figured, because one appears brighter, but it's actually further away, and...
Well, you're seeing the orbits in 3D, right? But they're projected flat on your sky, so this could be something that's passing, because they all orbit. They all go back and forth effectively across the disk of Jupiter here, in front of it or behind it, both in front and behind. So you don't know if this might be, say, Callisto on the far side, far away, okay, and that maybe even this is Io, but you know that's not Io, and you would know that that's not Io, because Io is never more than this distance away from Saturn on either side. It's always inside this distance. Europa is always inside this distance or so. So, but
How's
Callisto.
your tracking, Mark?
Huh?
How's your tracking?
Tracking is good. Why?
Good. Yeah, good alignment. I was gonna say one night, like when you're not streaming,
Yeah.
you should just take it and put it on Jupiter and just let the video roll and record it.
Oh, and
then
just
do
videotape the moons moving.
a time lapse of it of the moons moving back and forth.
Yeah.
So do an all night, time lapse.
Yeah, we could. It takes only a couple hours. We actually watched Io emerge from behind Saturn one night. Amanda was there. Remember that, Amanda?
Yeah.
Yeah.
Yeah, and if you do it for a whole night, since the orbital period of the red spot's only about 9 hours, you should be able to get that cross in the face, and you'll see the moons moving back and forth. I thought it'd be pretty cool.
You might be able to get that coming across. Not sure.
You'll get a slight movement. At least.
You will. See now here, Amanda. Look at. Okay, so there is Ganymede, just like you said.
Wow.
There is
Look
Jupiter.
at that flying away.
That's just and then you have Io, and Europa, and then of course Callisto.
Yay.
So you got it right. Nicely done.
Oh, that's Calypso.
Yeah, Calypso. Yeah, the things that you've shown us.
And the Pee Wee Herman song.
I remember Callisto because that was the name of a villain in Xena, warrior princess.
Lucy Lawless.
Lucy Lawless.
Yeah.
Grr.
I can't remember Callisto's real name. I think it's Hudson Leak. I could be wrong.
Okay, I think I don't know either. Shall we go to Saturn, folks? Let's see. Now let's zoom into Saturn right now and see what we can expect. Well, now we know.
Listen.
Yeah.
I think I may have interrupted something when I came in. Trish wants you to finish your school telescope story. Were you in the middle of a story when I came in?
Yeah, that's okay, Trish. I'll tell you.
By the way, Mark also said that he would leave his mark on observatories by destruction of private property.
Well,
just
unfortunately, I said that it happened unwittingly. So, Trish, yes, I will finish the story just for you. So nobody else listen. Okay.
He looks embarrassed, though. Thank you in advance, Trish.
Hi, Rochelle. Hi, Rastaz. So no, what happened was this. I was using the telescope. It was 3 in the morning. It was very cold. It was February. It was about 4 below in the dome. You can't heat a dome because the air has to be the same as outside. It was a vicious, vicious winter. And I had to move the floor up to meet the telescope. And that safety rail was all that prevented you from falling in between the telescope and the floor edge, because it has to come up over the pier, around the pier. So it collars the pier, and the pier got narrower and narrower as it got higher. And so the higher up the floor went, the more space was between the telescope and that fall to your death in the dark and the cold. So that rail with 2-inch steel all the way around was the only thing protecting you. And so the telescope has some appendages sticking off of it. One set of appendages is called setting circles. These are gigantic, massive circles. No lie, they had to be about 7 feet in diameter, about this high, okay, all the way around, made of brass. This was what's called an Alvin Clark refractor. It's a classic. It's a collector's item worth millions. And I was using it to do this project, and that giant circle is on a massive axis that's made of steel, okay? Well, that massive axis ain't moving for nobody, okay? And you have to be really careful how high you raise the floor, because if you're not careful, that massive steel shaft could hit the safety rail as the safety rail started to come up too high. Well, one of the program stars was way down near the horizon, so the telescope had to be tilted almost horizontal, and that meant the floor had to go way, way up high. And so I raised the floor up high. And the way I had the telescope, I should have, but didn't, notice that the big steel shaft was going to hit the railing. And the floor started going up, and all of a sudden I heard this. It was going. I'm hearing that noise and going, what the hell's that? So I stopped the elevator and started again. I was like, uh-oh, what's that? So I was about to go down to bring the floor down, get into the office, and make a call to somebody to see. But there was nobody up at that time. So I turned on all the lights. And when you do that in the observatory, your night vision's gone. And my blood ran colder than it was already running when I saw that big brass shaft had bent the 2-inch steel railing like a V. And I was like, oh. So for the rest of the night, I'm trying to figure out a way to straighten it out. And it just does not move. It's not going anywhere. It's steel. So in the morning, I went back, couldn't sleep, of course, because I knew I was going to be in such big trouble in my mind.
I can see you out there at 2 in the morning with like a blowtorch trying to heat up a railing, trying to bend it back.
No. The people nearby kept hearing a sledgehammer. Jing! Jing!
Yeah. Never heard that in the observatory before.
Oh, yeah, that's true. So anyway, that ended up being like a black mark against me, and the director chastised me. He said, what the hell were you thinking? I said, well, it was 3 in the morning. I was very tired. And he goes, well, it's a problem. I got to go to Saturn here instead of just
Mr. D'Antonio, do you realize that you're an astronomer?
Astronomers break things.
3 o'clock in the morning is your prime time, sir.
Yeah, that's true.
Well,
that's true.
Oh, you know what happens.
Yeah. And if that was the only thing that ever happened, that would have been okay.
Yeah.
But it wasn't.
Yeah. Who'd you kill?
No, when I was studying what are called runaway B stars, stars that they're Saturn, stars that are leaving our galaxy at high speed, I may have used a ladder to climb up and look through the eyepiece and guide an exposure on something other than my program star that I was supposed to be looking at. Maybe I might have done that. And that ended up, because of the nature of the way it was angled, all the program stars didn't have any danger. There's this gigantic, this is a 24-inch Schmidt-Cassegrain telescope that was massive. It weighed about a ton. And it moves very slowly, of course, because it's following the stars slowly. So I was guiding this exposure. I wanted a photo of M82, the exploding galaxy in Ursa Major, M82. It's a starburst galaxy. They used to call it the exploding galaxy. And M82, I couldn't wait to see it. And I was taking it on this really, really expensive glass plate. All right, glass plate. It was a glass plate photo, just like in the 1800s. And it was really a historic type exercise to do this historical plate. And I might have missed the fact that the ladder I was on was right near the telescope, and the telescope was so close to the edge of the observatory that it may have been possible that the telescope, over time, as it moved slowly through the sky, was going to slowly crush the ladder with me on it. I might have let that happen.
Lovely.
Yeah. And so what happened was, I'm shooting an exposure, and I'm an hour and 45 minutes into this exposure at the telescope's main eyepiece. And I suddenly feel like I'm being constricted. And I move my shoulders and realize that I can't. My shoulders are pushing right against steel. And that's when I realized, ooh, that's beautiful. Then that's when I realized, Cassini's division, look at that. We can see it tonight. Look at that. That's really pretty. Anyway, that's when I realized that the telescope was actually crushing the ladder with me on it, and it basically sealed me onto the ladder like folding, reclosing your Chinese dinner with those little tabs. Okay, and I was in a heavy fur outfit, parka because it was winter.
You look like an Eskimo.
I looked like an Eskimo and a half, yeah. And I ended up having to sort of slink downwards and leave my jacket up in the ladder to actually slide out of the bottom of the jacket to actually get out of there. And I got in trouble for that as well. I got in a lot of trouble for that. Look at it. We can see the crepe. Look at
astronomy
the
bad boy.
Well, not intentionally. It was the astronomy idiot. I mean, I mean, think about this.
That little dip in the ring there.
Yeah, this is. You can see Cassini's division very nicely. You can see the crepe ring here. That's really nice. But look at Cassini's division. Look at that. Cassini's division is an area where there's relatively few particles in the ring, and it looks like a groove all the way around the disc of the ring. And the disc of the ring is really not a disc. It's actually just a denser set of ice chunks, but they're really far away from each other. In fact, they're so far away, in fact, that the Cassini probe flew right through them and didn't even hit one. Okay, so that's kind of cool.
Sweet.
Yeah.
Yeah, it's not bad at all.
No, it looks pretty, doesn't it?
Yeah.
Let's get us there to this, and now let's try a little instant processing. Oh yeah, look at you can see the division right there.
Mm-hmm.
Yeah.
Yeah, and sometimes we get it like really good. Where there's just a nice clear line all the way around.
Yeah. Yeah. Well,
but
you're doing the right stuff, man. There's no doubt about it.
Yeah. Well, that's Paul's doing. He's a perfectionist.
Yeah. Yeah, so that's really pretty. And then also, if you notice, you can see some gradations in the clouds.
Dump the color out of it real quick.
What's that?
Dump the color out of it real quick.
Okay.
Let's see if
dump the color. Oops. Let me get out of that.
Whoopsies.
Dumping color. Here we go.
Subtracting color.
Removing color now.
All right, let's see that on the big. Well, that doesn't look like it's. Well,
hang on.
Maybe I just. See it right.
Hang
on.
Oh, I know why. Because I got to do this. Now it's black and white.
There we go. There we go. All right, so the color wasn't messing with it too much.
No.
Let's see how you can see that ring, like kind of going through, like you can tell the atmosphere, because you can kind of see the ring going through the top end of the.
Up here?
Very neat, yes.
Up here?
Yep.
Yeah.
Yes.
Yeah, there's a. That's a very special location.
Yes, it.
Fantasy is saying if you raise the contrast back to normal, you'll see the moons. And if you lower it, you'll get the details of the planet. Amal is dying to see the moons of Saturn.
Okay, well,
possible?
Well, what has to happen? Thank you, Fantasy. What has to happen is you have to do a longer exposure to see the moons. In fact, Titan is the only moon that's out here, and then over here we'll have probably Dione and Rhea. I think. Let me go back and look and see which moons are on the right side right now. I know Titan is. Okay. Okay, we have Titan. We have okay, so we have Enceladus to the left of the rings. Right here. And then to the right, we have Mimas down below the rings here. Mimas is very small. Then we have Tethys and we have Dione. And after that we'll have Iapetus down below. But we can do a long exposure to see these, and we will. Let me do a long exposure to actually check those out, okay? That's a star, not the moon. And we have Rhea is over here. Okay, so there we go. So let's go back, and if you want to see the moons, all we have to do is go back here. And now what I'll do is do a longer exposure, and I'm doing it, and you'll see the moons coming in here right now. Okay, and you can see them. However, what I want to do is I want to increase the sensitivity so that I don't have to go 30 seconds.
I just heard a bloop.
Yeah, that wasn't me. That was Amanda.
How is it me? I was the one that sent the message.
Oh, that calls. No, that was on my end. I heard the bloop. That's because somebody sent a message.
Oh, yeah, I sent the message. Yeah, we have a question. But I was going to patiently wait, but now that we're discussing a little noise.
I'm going to do this. Okay, 1600 at 8 seconds. I'll go up to 10 seconds. And now we'll see some of the moons, maybe not enough. We'll do 13 seconds. There we go. Okay.
What if all of a sudden it came on, there's like a big saucer? Just like right there, real close.
Yeah. What's the question, Amanda?
Genghis wants to know, is it common for gas giants to have hexagon formations at its poles?
Yeah, actually, we actually don't know, because we have to check out the other gas giants to know. But that looks like it was a resonant feature of the Saturnian atmosphere, which is really cool, you know. So maybe it is. We can only wonder. You know, we don't really know. So here is Saturn with its moons. I think if we go now to our sky here, okay, Mimas is very tiny down here. I don't think Mimas is gonna be. Mimas is probably lost in this. This I gotta see if that's Mimas. That looks like it's too far away. Let's see. That's Iapetus actually. That's Iapetus, which is down here. And then we have Tethys and Dione to the right. That's Tethys and Dione. That's Titan. You can see the orangey color of Titan. That's the heavy-duty nitrogen atmosphere. And we have two over here and one there. Let's see if that's Rhea, that's for sure. And let's now look see which one is going to be Europa. Or, I'm sorry, Enceladus. Okay, so we have. Okay, there's Rhea. All right, there's Rhea there.
Yeah, Fantasy saying once you lower the brightness in live, the planet shows details, but you made it too dark to see the moons.
Well, yeah, I mean that's a common problem we have, unfortunately. That if you want to see the moons, you got to overexpose the main planet. If you want to see the planet, you got to underexpose the moons. Yeah. All right, so we have Rhea up here, and then down below, right near Saturn's rings, we should see Enceladus. And there it is. See, here is Rhea, and there's Enceladus. Okay, right there. That little dot right there that you see in this image, that is probably a location where we may find microbial life on the bottom of its south pole, because it definitely has an awful lot of potential there. We've already identified hydrothermal vents in the south pole of Enceladus. Enceladus is this moon's only 310 or so miles in diameter, really small. But we also know that this is basically an area where we're seeing geysers of water shooting off with some very interesting materials as well, including things like carbon compounds. That means that we could be seeing the formation of potentially life underneath the icy crust. Just like Europa at Jupiter, Enceladus, smaller though it is, has an icy shell around it with potentially an interior ocean down to a certain depth, and then it's rock. So we could be looking at life right here and not even know it yet. You know?
Aliens.
Yeah. So that's the overexposure to show you the Saturn environment. And there is Titan out there. Titan is actually sort of a snapshot of the Earth, but in deep freeze. Primitive Earth in deep freeze. We were never in deep freeze, but if we were, we would actually have looked at one point similar to Titan. And Titan is sort of a learning environment for us about, and it has to do with finding
so
Earth.
Close yet so far away.
So close yet so far away. That's exactly right. Yep, that's exactly right. So anyway, there we go. So let's go back and see if we can tease some more detail out of Titan. We're gonna tease Titan, folks. Look out. All right. So we'll bring this down. Actually, I'll take one more shot. Do 800.
How are we able to see the further away planets, like Neptune and Uranus?
If they're up, we can see them. Yeah, when we
No,
look
I know, but like, how are they even being illuminated? They're so far from the sun.
Yeah, they're reflecting the sun's light, and that's how we see them. You know, I know that doesn't
So far away, like if like, not that you could stand on Uranus or anything because it's a gas giant, but like
Correct.
if you could, and you looked back towards the sun, wouldn't it just look like a little white dot in the sky, like a star, like any other star that we see in the sky looking up?
No, it'd be brighter than the average star, but it would be
Hey, boo boo.
that's right, you got it. It'd be brighter than the average star that you'd see. So yeah, the sun will be dimmer, okay, and the intensity of the light falls off as the square of the distance. So if you're 4 times further away, it's 16 times fainter. So the light out at Neptune is going to be fainter by far, yeah. But Pluto's even further, and the light to Pluto, still, that the energy of the sun is still enough to cause some of the melting of the nitrogen ices on the surface of Pluto, which gives it what little atmosphere it has. So you see, the sun is a very powerful object and has a great reach, you know. So, and beyond that, objects out in the Kuiper Belt are going to be far enough away so that the sun's energy doesn't do any appreciable heating on their surfaces. And so objects that could be comets stay inert and in the deep freeze.
The heck is that noise? Oh, that's the music.
Yeah, someone asked if you could turn the music down a little. I do hear that your audio is cutting a little bit in and out, Mark.
Okay, I have to check the microphone, because the microphone might be having some issues too. Because when I listened back, I heard times where my microphone suddenly went very silent.
Yeah.
And I noticed my settings in OBS don't change, so I couldn't understand that. Of course, yesterday I had music playing as well during the stream, and my outgoing levels were showing music going out, but I played back the stream and I couldn't hear any music. So how could it be going out but not actually getting to the stream? That really was perplexing.
Oh my.
Yes. Thank you, Mr. Sulu. George Takei. Yes. Yeah. So anyway, let's take another picture of.
Hello.
Hello. Yes. Ha ha ha.
Ha ha ha.
Yeah, George Takei was just—he's a funny guy. I almost had a chance to have dinner with him because one of the people that knew him said, "Hey, you want to go to New York City and hang out with George Takei?" Yeah. And it didn't end up happening, so I didn't go. So that's all right. You don't count those chickens.
I had a chance to have dinner with Sulu.
Well, apparently he's a very funny guy, you know?
Oh, yeah.
All right, let's see what we got here. Okay, there we go.
My favorite drop ever on the Stern Show is George Takei saying, "Hey, boner." He was talking about that guy. What was it? No, it wasn't Happy Days. There was a guy on a TV show called Boner, and
really,
he called into the show, and George Takei just went, "Hey, boner." And it's the funniest thing ever. But I forget what show. Somebody knows this in the chat. Whatever show.
I want to say Growing Pains, but I can't confirm that.
Yeah.
I can either confirm or deny because I did not watch that show.
No, it wouldn't have been that.
It was a show like that though. Oh, was it? What was the one with Kirk Cameron?
That was Growing Pains. That's what I said.
Okay. Yeah.
No, because there was an episode, and I remember I was really young when the episode came out, and I don't know if it was a dream sequence or what it was, but the younger brother Ben was in like a dream sequence or something, and his friend came in and he went, "He's a weenie," and it was like the funniest thing, and that was like a catchphrase for like a week.
I need to find that when he did that on the Stern Show and have it as like a.
That's funny.
Put it on the soundboard, so every time like it just gets quiet, you just be like, "Hey, boner."
It might be from a movie, I want to say.
Yeah,
no, it's definitely a TV show. There was a guy, boner, no TV. I just don't remember what it was.
Trying to figure out a
Help
way
us out,
to
chat.
cause trouble.
I'm gonna have to Google. See, you're gonna make me Google.
I was gonna say, if you don't help us, chat, I will go to Google. Yeah.
Yeah.
That's okay.
But then again, actually, you go to Google, Keith. I'm scared of what might come up if I Google that.
I know. Right? Yeah, I'm just gonna see a bunch of dongage all over the place.
Yeah. My virgin eyes can't handle that.
Yeah, we'll never look up. Hold on. Let's see. Oh boy, here we go.
Here we go.
Yeah, it was Growing Pains.
Ah.
Oh no, Boner's
Wasn't his name Stinky or something like that? Wasn't that the friend's name? That's why I was doubting myself.
I didn't know Boner died.
Did he?
Yeah.
Couldn't have been that old.
Said famed as Richard Boner Stabone, buddy of Kirk Cameron's Mike Seaver character on Growing Pains, which aired on ABC from 1985 to 1992.
Kathy Pernasek knew.
Kathy Pernasek. She knew it.
I do want to make sure that I say hi to Justin T, who's here. Go Captain America. Kurt Horn, thank you so much for coming up out here. I said hi to Amal, but I'll say it again. Hello, Amal. You guys are fantastic for helping out here, keeping us going. And of course, I want to thank you, Amanda, for joining us. It's wonderful for you to come over on board, as always.
I just woke up. I'm sorry. I've been asleep a lot, guys. That's why I've been missing the last few streams. So I apologize for my absence, but thank you for the warm welcome back.
And I do want to say hi to Johnny Yu. Hello, Johnny.
I remember
Hi,
what
Johnny.
I looked up Gary Oldman and forgot the R, and that was traumatizing. But hey,
Nope.
what happened?
he just told you a fib. He didn't do that. He's making a
I did
joke.
too. It happened 2 years ago, and you can go back on my Facebook and look because I was traumatized.
Yikes.
I'm serious. I typed it in, but I thought I pressed the R, but I guess I didn't, and I looked up Gary Oldman.
Yeah. What comedian?
That was a surprise. That's not what I was looking for, but
what comedian has that? What comedian does that joke?
What joke?
And the one you're looking up Gary Oldman and you forgot to type in the R. I mean,
What? It actually happened.
It did? I thought that was
Yes.
a comedic thing. A comedy
Yes,
bit.
absolutely funny. I agree, but it actually
Oh,
happened.
jeez. Okay.
My. Yes.
And so to continue, I want to say hi again, of course,
Well,
to
it's
Kathy.
not the only one.
Say hi to, let's see, who else was I going to say hi to? Oh, Genghis. There he is. There we go.
He's such a good actor, too. Like, he blends into every role he plays. Like, you almost don't know it's him.
Okay.
He's a good actor, man. You don't like Gary Oldman?
What did he do? I don't know what show he was
Oh, holy. He's one of those. Well, he was one of the uncles in Harry Potter. He was Commissioner Gordon in Batman.
Which one?
The one with
Adam West?
No, the other one, the newer one. Not Batfleck, but the one before him.
Oh my gosh.
Oh, that was
Where'd it
Michael
start?
Keaton.
Not Michael Keaton?
No, with the Dark Knight Rises and all that.
Oh, no.
What's his name? The other method actor.
I don't know.
Yeah.
Chat?
The newest Batman. Well, not the newest.
Are we
but
going to Google a list of Gary Oldman movies? Does
Don't
anyone
forget the
dare
R.
drop the R?
Yeah, don't forget the R. But yeah. I mean, he's been in so many things. Like, he just blends into every role, and you can he actually is like one of those actors that passes off as like he can play like any role. It's really crazy. And you don't think of him as like Gary Oldman. It's just
Christian Bale?
Christian Bale. That's it.
Thank you, Go Captain.
He was Commissioner
Excellent fur.
in the Christian Bale Batman.
I don't think I saw that one either. Oh, was that the one with Katie Holmes in it?
I don't know. Oh, the new. Well, yeah, I think so.
Okay, I kind of remember his face in Batman. Yes.
Yeah. But he played one of Harry Potter's uncles, and he looked totally different. And then he was in a lot of other things too, and he never looks the same in any movie.
All right, well that's pretty cool.
Oh, yeah. There's tons of actors like that, but he's really good.
Yeah. All right, there's another object I want to go see. What's that?
Snoop Dogg as Batman would be great.
Wouldn't that be Dogman?
Bat Dog.
Yeah, Bale's Batman was okay. I didn't like the whole boys thing, but it was a good portrayal when he was being Bruce. But when he was being Batman, you just wanted to tell him to get the boogie out of his nose and blow his nose or something, because he was always.
Oh.
Was he the one that had the meltdown on set?
Oh
Started
yeah.
Yelling at like the production crew or something.
I remember that clip too. He was like, "Oh, good for you."
That's all I remember about him in that movie.
Yeah.
Well, you guys have seen a little more movies than I have. Actually, I'm sort of science fiction centric. I don't typically go beyond science fiction. I don't know why. By the way, I'm heading to a measure object right now, M75.
Wait, what's your favorite sci-fi movie then, Mark?
Well, there's several, but
Your favorite? Pick one.
Or favorite movie in general. Doesn't have to be sci-fi.
okay,
Probably
well,
will be, but it doesn't have to.
There's a number of sci-fi movies that are great, but one of the ones, of course, if we go to classics, then I go to one that I couldn't understand at all as a kid, and that was 2001: A Space Odyssey. And when I found out that one of my best friends is the guy that did the visual effects for that show with Stanley Kubrick, I became even more interested in it. And of course, that's Douglas Trumbull.
Am I just one of the that just don't get that movie? Like, I don't get it.
That's what I was saying. I didn't get it either. My father brought me to see it when I was a kid, and I thought, wow, 2001: A Space Odyssey. and it opens up with monkeys.
Yeah.
And
Well,
they
I
touch
get
this
like,
black
I
thing.
get it.
And they fling a
As
bone in
they-
the sky, and it's like, what the heck is that? Oh, okay, a spaceship.
Yeah, I
And from
understand
there it
all
was
that,
okay.
like, and I understand the visual effects were, groundbreaking. But as for the actual movie plot itself, like, I don't get it.
Yeah.
Like, going to space, a computer wants to take over. He ends up in a room, and he's back to being a baby. Like, I know there has to be some kind of hidden meaning in there because it's Kubrick, but still, it's very poorly done.
Well,
but it's revered, because of the effects of the movie.
Well, no, actually, it's revered because the story was so groundbreaking. It was a groundbreaking story.
What am I not getting? Explain it to me. What am I not getting about it? Am I missing something?
Well, it's the monoliths represented a symbol to the alien race that humans have reached a level of technological proficiency that now meant they could evolve to the next state.
Okay.
So when the
monkeys found it in the beginning, that means they got to evolve into human beings. And then when we found it on, was it the moon or Mars? I forget.
Moon. And actually in Tycho Crater. It was.
So when we found on the moon, they were ready for a spacefaring race.
Well, definitely, when they found it on the moon, it meant that now we're spacefaring, and then that's when all this other stuff happened, and the hell was actually being controlled not by anyone on Earth, but it was being controlled by the alien race, and it picked Bowman as the star child that would then come back.
There was an alien race? Okay,
Yeah.
I did miss a whole, but I gotta watch that again.
Well, I mean, yeah, these monoliths didn't come from nowhere. This M76 is a little tiny Albireo cluster, by the way.
I know, it's pretty.
It is pretty, but it's sort of in the murk. But I wanted to check it out anyway because it was in the murk.
I wrote that down. I'm gonna give 2001: A Space Odyssey over the next couple nights when I go to bed.
Keith, Kathy said she didn't understand the ending either.
Okay.
Yeah, and 2010, the year we made contact, was really good. All these worlds are yours except Europa. Attempt no landing there. Use the others together. Use them in peace. That's wonderful. But now these aliens said, I can't go to Europa anymore. Darn it all, we want to see if there's life there. What's interesting is, and fascinating, is that when 2010 was written, we didn't know a lot about Europa. Yet it turns out that Europa is the most interesting and potentially life-bearing moon of Jupiter. And I find it fascinating that with the latest understanding of Europa, that science fiction looks like it's becoming science fact, and the fact that Europa might be the only one in that area. But you got to understand too that Jupiter has a magnetic field 20 times the size of ours, and so it traps more solar wind, which are the protons and electrons coming from the sun. And these protons and electrons coming from the sun getting trapped cause problems, because these little guys are going to be held in Jupiter's magnetic field, and this means around Jupiter that we're going to have a radiation belt around Jupiter that's extremely potent. Now we have the what we call around our planet the Van Allen belts. The Van Allen belts are nothing more than our magnetic field and the magnetic field lines trapping solar wind particles that are coming into our magnetic field, into our magnetosphere, as we call it. And so that creates the radiation field around the Earth, which is the Van Allen belts. There's several, and they're different altitudes. Well, these belts are also a source of danger for astronauts. We have to be careful how we go through them. We have to be careful how, if we go to Jupiter, we have to be careful how to deal with 20 times the intensity that we have here, actually more. And Europa is certainly bathed in these belts, so any life on Europa will have had to evolve in this type of environment. And we know that life has a way, okay? And being that life will find a way, we do know that just like in our deep ocean, where life can exist under crushing 10,000, 8,000 pounds per square inch of pressure, we know that life might also be able to evolve in areas where the radiation and the habitability for humans is absolutely non-existent. So it's kind of a cool thing. So I'm looking forward to the Europa Clipper mission, which is going to go out to Europa.
If anybody likes like real good sci-fi, there's a channel on YouTube called Dust.
Oh, I love that.
And they are constantly every day putting out new content from filmmakers and stuff. That's all sci-fi. That's all it is. And it's a really great channel.
Yeah, and all the movies are about 12 to 20 minutes long. They're shorts, but they're really cool. If you want to spend the night just having fun, go to the Dust channel on YouTube and have fun zipping through. I do it all the time. I just did it.
Yeah.
You know?
Yeah, I mean every one of them is good. They're thought-provoking. They're really well written. They're smaller productions. Some of them have some corny CGI because they don't have big budgets, but other ones are really good for what they are. And you can tell people took their time with it. You know, and sometimes they have interviews with the directors and they tell you at the end what they were doing and what they were trying to make people understand. It's a really good channel. So Dust, just look up capital D, capital U, capital S, capital T. It's a really good channel.
Yeah, and there's a movie I think they make that I thought was really cool called FTL, which stands for Faster Than Light.
Yeah, I've seen that. It was really good.
FTL is about using the Alcubierre drive that I talk about quite a lot. And he goes out to Mars. Okay, the astronaut goes out to Mars. Wow, he did it successfully in like 8 seconds, which is about right. And then he tries to start it up again, and it ends up having a mind of his own. And then he's transferred so far away, the ship, has problems happen, but you got to see the rest to see how it goes out, how it turns out. Really, quite a beautiful, vision. In fact, Katie Q, you caught me. Yeah, I had this Christmas music showing up out of nowhere in my list. I deleted that. Yeah, that was wonderful. It's like, March of Christmas in July. Hey, you know what? I think it's always Christmas when you got people like you around. You guys are amazing. So there. What do you think of that?
Very good.
Yeah. Okay, so let me go back and find out where I'm looking here. Okay, we
have a few questions coming in too, by the way.
Okay, let's hear them.
Okay, hold on. Let me find them. Ronald wants to know why I'm not sure, it might be a typo, why the moon's rocky of the gas giants. I'm not sure exactly what that means. Why are the moons rocky?
Why are the moons of the gas giants rocky?
Gas giants rocky, maybe? I don't know. Ronald, do you want to rephrase that, please?
Yeah, Ronald.
Are the moons of the gas giants rocky?
Oh, what's the
whereas
being asleep?
The torrential aren't?
Ronald.
That's okay. He'll get to it. I'm actually going.
Anyway, Go Captain wants to know if you saw Ad Astra. Do you know what that is? I don't know what that is.
Yeah,
yes.
I did. Actually, there's another movie called Into the Unknown. And Into the Unknown was about one man heading to Mars. And a lot of the spacecraft in that movie, I think it's won a lot of awards. A lot of the spacecraft in that movie, I actually helped make, because I was actually, that was filmed up at the studio. And they had, initially in the design meetings, they had spacecraft that it couldn't work. They were spacecraft that they wanted to have this one barrel spacecraft. The barrel had like a tube, and have this thing orbiting around it on a truss. Okay, and they just wanted to do that. And I said, well, in space they would start orbiting each other because there's no force to hold that bigger one back. And then I said, you need to add another truss on the other side to make a counterweight so that they could spin with a counterweight. And the art director looked at me and said, we've designed our ships, thank you, okay? We don't need your help. And Doug said, Mark's my chief scientist. If he says it's not going to work, I think you might benefit from listening to him. And right on the heels of what Doug said, the guy turned to me and said, so tell me how we have to change our ships to make it work. And it's like, well, I'm not trying to, be a big shot. I just want to share with you that, it's about balance, especially in space. And they did. They changed them all around, and what they made was good, because these wouldn't have worked on the rigs that we were using to actually spin them either, because it would have had all this unbalanced stuff. Once it's balanced, it was beautiful. I got a lot of photos of the production that when we worked on it. I probably have to share with you at some point, because you guys might like that. So this is the little Gem Nebula, and the nebula is a planetary nebula, and it is. Let's see if we have the distance is about 6,700 light years, and you can see it just barely right here. It's this little blue thing. Amanda likes little blue things like this.
Yeah, we did figure out what Ronald was trying to ask.
Oh, okay, good. That's what I was waiting for.
Yeah, it was basically what I was thinking. Why are the moons of the gas giants rocky? Genghis also wanted to add, because he was curious about it too. Can moons be gaseous bodies versus rocky? That's interesting.
It's an interesting question, and the answer to that question is, moons can have an atmosphere, so they can have a layer of gaseous substance on them, like Titan. Okay, Pluto was, and so forth is a dwarf planet, and they can have an atmosphere as well. But as far as being gas giants, no, there's no gas giants that are the size of small moons. The gravity has to be substantial to retain it, and the small moons don't have the gravity to retain it. Those are called volatiles, and they're volatile, meaning that it doesn't take much for them to go away, and to be evaporated away. So we wouldn't see anything like that. But that's a really good question, though. And so as far as why the moons are rocky, Ronald, the question is why, when we look at the moons, how come if we look at the moons and see that they're rocky, it's because of the fact that I just sort of explained, since we can't have any gas giant or gas moons, the only alternative is that the remaining debris in that system that forms any kind of object is going to probably form a rocky moon. And most of the volatiles will have been swept up by the major volatile collector, which is the big gas giant itself. So that's kind of how that works. This looks pretty, but it's a.
What is this?
This is the Blue Gem Nebula. I'll show you. It's called the Little Gem Nebula.
It's lovely.
It's also called the green.
Wait, why have we not seen this before? I don't remember seeing this before.
Okay, it's also called the Green Mars Nebula. Yeah, I just told you it's 6,700 light years away, and it's a summer sky object. We haven't seen it, but I actually need to take a longer shot. This was only 5 seconds at 2,500. I'm gonna actually go up here to like 25 seconds, and this is a visible light shot, by the way. So if I take it with a filter, it's gonna look far better. So let's do 2,500, 4,000 at 2,500, 4,000 ISO 20 seconds. And the little guy's right there. Oh, you can't see that. All right.
And we have another question.
Okay, shoot.
Okay, Fantasy wants to know, if you had to plan a mission to drill the oceans of Europa, how would you plan it? The mission's objective is to send a submarine into the oceans.
Yeah.
Go.
Well,
I need $400 billion.
That's a good start.
You can make anything happen with that. Okay. Well, first of all, let's just take a look at the little gem. This is a beautiful little nebula. I could probably reduce the amount of the ISO just a little bit to give us a cleaner looking image. So I'm at 4,000. I'm going to go down to 2,000. All right, and we'll do it again. Leave it at 20 seconds. I could go up to 25 seconds. Okay, so how would I do it? Well, to be honest, we're not. I wouldn't want to drill the oceans because if there was life there, we would actually have a problem. So we'd have no choice but to try and drill down the ice cap. The problem with Europa is the ice cap is extremely thick. It's thicker than any ice cap here on Earth. It goes down many miles, all right, in depth before you actually get to the internal ocean of Europa. So we would literally be drilling for a couple of years, maybe more, to get down there. So whatever goes there to do this would have to do it in an automated way. And we are tuned to creating lightweight craft to do lightweight tasks. You know, Curiosity is one of the biggest things that we landed on Mars. It's the size of a Volkswagen Beetle and about as heavy. And it's still tooling around since landing 2012, I believe. That's quite a long time considering it was meant to live 90 days. So we could conceivably create something that could do that, but how would you get the next segment of drill pipe put on? You'd have to have a huge supply of that. Or you have to have the unit itself be not only the drill, but the submarine itself. So it would actually go down. It would leave a system on the top that would be a communicating beacon, and then drill, and just drill for as long as it could with the solar panels on the surface providing power to a wire all the way down to wherever it is. The wire has to be miles long, and when it finally gets to anything that might be water, then it has to drop the drill piece or the drill elements and go into submarine mode. That's what I would do.
What if, okay, let's say we were able to build it in orbit, okay?
Yeah.
So we build a machine and almost do like the kind of Russian nesting doll thing with an auger.
Okay.
We then, if it was built in space, we really wouldn't be held back by size per se. Depending on how we do, like if there was such a thing as a space elevator, obviously it'd be a lot easier. But
yeah.
What if they built? I mean, you could build this gigantic machine, you know, with the whole Russian nesting doll kind of thing to it with an auger, and then launch it already from space to Europa to start the dig, and maybe have a, 2 or 3 or 4 mile, I mean, granted, by the time you get down to where you really want to be, the auger itself might only be, the size of a quarter, but you'd still be able to get and extract water and stuff.
Or even see that it's there.
Right.
Yeah.
That's a possibility if we were able to construct it in space already.
Yeah. I don't disagree. That might be a way to go. It might be a good way to go.
We'd never be able to do that from having to launch it out of Earth's atmosphere, I don't think.
Well, but the mission would be a small craft. It wouldn't be a large craft.
But I'm saying if you were to dig all the way through the ice shelf of Europa, you're going to need a large craft to actually house all that equipment.
Maybe not.
To dig.
Maybe not. If it's just a functional, cutter, and a functional submarine, it could be a probe that doesn't have too many instruments on it at all, or they could be on the inside. And then once the cutter got through, it could just shed the cutting tools, and then rotate out all the internal tools that turned into a submarine.
I see what you're saying now. So basically, like we plant a craft that has a cutter on it.
Yeah.
And when it lands, it sets up like a couple panels, and maybe it has miles of,
exactly.
wire.
That's right.
To power.
That's right.
Okay.
And as it drills down, maybe it has to wait, like a couple days in between each dig segment because it needs to power up again.
Right.
And as it digs down, then it can actually, recharge its batteries. And it will do this. When it lands on the surface, the first thing it does is the landing pod, when it opens, is going to auto deploy solar panels.
Right.
Okay. And those solar panels are going to be able to hopefully follow the sun, which is not going to be very bright out there, but it's going to be more than a Saturn, for Europa. So the ice at Enceladus, the South Pole of Enceladus, is a distant target. I mean, that's going to be another one. And before we go to Enceladus, we're going to go to
to
Titan again.
I was doing a surface digger, and you were thinking about an actual craft digger.
Yeah.
And your way is a lot easier, to have it powered from the surface and only have to actually power it with miles of cable.
Oh, yeah. And I think that maybe what we could do with something like this is the digger itself is the submarine.
Right.
And that kind of, it limits the instruments you can carry for the submarine part of it, but it gives you some very interesting data about the depth of the ice, the density of the ice, what kind of chemistry is the ice.
Well, not only that, but those would have to be protected kind of like in a Faraday cage kind of thing, wouldn't they? Like in their own little way? Because any unknowns to affect the equipment. And
I think that they would have to be protected. But the other thing is, too, we can't predict, for instance, how the sun is going to affect these objects way out there, Right. We know how much energy that the sun is emanating. We know how much the solar panels will charge. What we don't know is what will be the effects of, we have an idea, what the effects of Jupiter's radiation belt will be on this craft. Is Europa far enough out that it dips in and out of the radiation belts? Or if the sun is active, those radiation belts are going to expand and cover more territory. And when there's less active, they'll cover less. So will things expand, or will they actually contract, and cause problems? I don't know.
Yeah, and you're also going to need communications there along with the solar panel.
Yeah.
Communicate data. So yeah, it'd have to be it'd have to deploy solar panels and a little data center that's protected. And just in case it gets into Jupiter's, hotspot, if it does.
Yeah.
So yeah, there's a lot involved with it, but yeah, let's do it.
Yeah.
Want to build it? Want me to come over this weekend? We'll build that.
Yeah, you got some graphene? We'll probably need that.
Sure. Yeah, absolutely.
Okay. Amanda, you got another question?
Some pencils?
A follow-up from Fantasy. How would you fix the auger, though, if nobody is there? That's the dilemma he's trying to figure out.
Oh,
well, in the same way that we have the any problems with rats on Mars, okay? And what do I mean by that? Rats, rat isn't the animal. Rat is the rock abrasion tool on the rover. Spirit and Opportunity each had rats on them, which they're these little tiny wire brushes. They would go down near to the rock, and they would spin and scrape the rock, and then they'd study the rock with a microscope built in. Well, if there was problems with this stuff, how do you fix that? We didn't have a way. There's no duplicates. There's no backups. But if JPL and the other companies that build these spacecraft are any indication, the longevity of all these missions to Mars, for instance, has far exceeded the warranty by so much time and capabilities that
very good track record.
Yeah, the track record's outstanding. So I would say we just have to make sure that it doesn't break down, just like Spirit rolling on these metal wheels was great for years until it finally.
Just like we're gonna have to do James Webb. Oh man, I'm still nervous for that. But
I know. Okay, but like the rover, like the Spirit, finally got mired in a dune and couldn't get out, and one of the wheels locked up. Probably got some grit and rocks in there, and the bearing seized finally, and it couldn't move. We still could get science done, but it wasn't as complete. Opportunity, we lost its signal after a large dust storm, and so the panels were probably covered with enough dust so that Opportunity couldn't charge up to its threshold levels to get out of sleep mode. So it's stuck as well. And the longer that they go without battery charge, the longer the cold has a chance to deteriorate other systems. Remember, the concept of a superconductor? The colder you get a conductive surface, the easier electricity could flow through it and on it. So when this happens with a question comes like a Martian rover, the temperature gets down to like 100 below zero maybe, and that's kind of like superconductor temperatures in a way, and so a battery would basically continuously drain, and unless the charger could overcome that, then there's no chance that it could recover, and there's only a certain amount of time that the batteries can even operate and take a charge, just like with your car. So the longer opportunity is without power, the more likely that it's fully dead and cannot be retrieved and recovered unless somebody goes and puts some new batteries in for it to charge. Okay? Curiosity, on the other hand, is still tooling around just fine, but Curiosity has a nuclear reactor on it, essentially. And Curiosity's power doesn't come from solar panels, it comes from a nuclear reactor. And so it'll have power for years and years and years to come. Now, see, I thought of something. How long would it take Curiosity to get to Opportunity and affect the repair? I mean, it's possible that Curiosity could somehow be instructed to clean the solar panels on Opportunity. Maybe. I don't know. Just a thought. And Ronald, your question is, what is that blue? Why is that blue? Okay. Well,
hold on. Well, that actually goes with another question.
Okay.
Genghis asked a while ago.
Okay. Fair enough.
He wanted to know if there was a lot of oxygen in that nebula versus little to no red hydrogen. Is he on the right track? Or
yeah, Genghis, well done.
Yay.
Well done, Genghis. And what we're seeing in this nebula is it's a planetary nebula, and you can see some detail in here if you notice. It's pretty interesting. It almost looks like a plus sign. I'd be interested to see a Hubble shot of this nebula, and maybe some of you can go check that out while we're waiting. It is NGC 6790. All right. Let me make sure that's what it is. Yeah. This is 6790. And it's just a very cool little planetary with some structure in here. Now, when we look at the nebula, planetary nebula, this is a lot of oxygen, ionized oxygen. In the middle is a white dwarf. We can't see the white dwarf tonight very well because the sky is not really good enough. If you see this modeling and stuff, we have light clouds, and we're kind of at a disadvantage. But when the star is finally shedding its outer layers as it becomes a red giant, there is the likelihood that it formed with a lot of oxygen in its atmosphere, because oxygen is formed in the hearts of other big stars. And when those stars go supernova and spread the stuff to the interstellar medium, when new stars form, they form with a healthy component of some of this oxygen. But they're always mostly hydrogen. The oxygen is just a small part, very, very tiny part in the star's atmosphere. But it's in the outer atmosphere. When it gets blown off in the planetary nebula, then the white dwarf is very, very hot, like 50,000 Kelvin. It's extremely hot. And it will have mostly ultraviolet radiation coming out of it. That ultraviolet radiation is going to ionize the oxygen, twice. So two of these electrons are going to get, thrown off the atom. And then when they recombine with the atom, they're going to end up giving off light as they lose energy. That light is this characteristic blue color. So there you go. A longer answer to this question, but that's why it's blue. Now, we don't see the red of any hydrogen or of neon, incidentally, but that could just be because of the fact, and it doesn't have to be there, but it could just be because of the fact that this nebula predominantly only had an oxygen envelope that was sprayed off into space. That's all. So I think that's kind of interesting. So I think that answers your question, Genghis and Ronald. Yes?
I hope so. I'm sure they'll let us know in chat if it didn't.
I'm sure they will.
And one last question so far. Keeps them coming, guys. Another question, I think maybe when Fantasy was talking about drilling, made Go Captain think, could we contaminate the moon by drilling due to our microbes on the equipment? And Curtis suggested maybe we could clean it with radiation. That might not be 100% though. How do we avoid that?
That's all extremely prescient questions. Well done. I think that one of the things that we want to consider is that when we're looking at an object like not our moon in particular, but say Enceladus, we have to go at this like the Federation in Star Trek. We have to consider that there might be other life forms there, and our presence, just our mere presence, could constitute a threat. And that is something that
we're dangerous.
We are.
We are.
Yeah. And that's something that I don't think that anyone really wants. You know. With the moon out, by the way, the blue glow was rather intense. So that's what we're seeing here. So let me just do one thing. And I'll get back to the question here in just a second.
Yeah, that music got loud all of a sudden.
We do take a lot of steps.
And I didn't see
equipment.
I didn't touch
for
it.
Protection.
Yeah.
You know. But there's always a chance.
That's right.
Stupid humans ruin all of Europa with microbes.
Exactly.
I can see that. You know, there was life until we arrived.
Yeah. Well, it was here, but like that Star Trek episode. It was, but not anymore.
Newspaper just says sorry.
Yeah.
Our bad.
Yeah.
That made me think of an old Dennis Leary skit coming out of rehab, but I can't say it on air, even if we are 18 plus, because this is a family-friendly show.
Family friendly.
That is correct.
But for anyone that remembers Dennis Leary's No Cure for Cancer, he came out of rehab and said, sorry, and followed by another line, but I can't tell you.
Yeah, you
worth
can't.
a listen, for sure. Definitely worth a listen. Check it out.
Yeah. Don't you do, you still do your comedy shows on ERT?
No, I haven't done them in a while.
Oh.
Those were fun.
Yeah.
I mean,
You always did
that's
such a
how I
nice
grew
job.
up, listening to the Sunday Night Funnies on the radio.
Yeah.
Listening to an hour or two of comedy before bed.
Yeah.
For school in the morning.
Yeah, I did the same thing, but it was like, there was a radio show I used to listen to all the time. It was really funny. You know, I can't remember right now what it was, though, for the life of me. I just remember one time I was laying there listening to it, and after midnight, all of a sudden I heard someone whispering my name through the radio. And it really freaked me out. I heard, Mark. I was like, what? What's that? Mom, is that you? Mark. Ah! It was actually really freaky. I never got an answer to what that was. But shortly thereafter, I felt like going out in the dark at night and just walking long distances and, you know, not looking behind me, even when I heard noise and breathing. I don't know what it was.
Yeah. Hate when that happens.
I don't. All right, so I was trying to do something here, and it's not gonna.
Next thing, you're butt naked in the middle of the woods.
Never that bad.
Okay, well, I was young. I needed the money.
Jeez.
What?
Yeah,
what are you looking for there, Mark?
Well, I'm just looking. Oh, I'm sorry. I'm show you what I'm doing. I'm actually trying to. I'm just seeing that the moon is still up here, and so that's gonna spoil a lot of our views of anything we might want to see here. So I'm trying to see if we can find another object that might be worth looking at.
Where's Mars right now?
Oh, Mars is gonna be out here.
Yeah. I haven't been paying attention to Mars lately.
Yeah, I don't think it's up yet, but it's gonna be up.
So it's starting its crest back to the evening sky again.
It is an evening sky. It's just, you know, if you go out at like 2 in the morning, it's you see, you have Jupiter, you have Saturn, and you'll have Mars over there. You know,
right?
And it's got to rise yet, I think. I can't see with this observatory in the way. Okay, well, let's try something else. Let me try, since we're here at this guy, I did want to try and look. I don't know if it'll work. Yeah, we're not going to be able to see it with the...
What's up around Zenith? Anything cool up around Zenith right now?
There's always the... Yeah, I mean, we got the Ring Nebula right here, but, you know...
I don't even know where we're looking.
Huh?
We're looking southeast.
Well, now we're looking up top and see what this is, the southeast side right here, yeah.
Top.
There you go.
What's a Graffs Cluster?
Where?
Right there to the right of your pointer. To the right, no, we're back down here. It's out of view. Oh, wait, I'm looking at the wrong... I'm looking at YouTube again. Ed.
What are you doing?
That's why we weren't lining up.
Yeah, that's why I give this to you.
Anyway, there's a thing on there that says Graffs Cluster, and it's up near the zenith point.
Okay, well...
A little down towards the southwest.
Okay. Well, we have the Angelfish Cluster. We have the Mothra Cluster. And there's Graffs Cluster there. Okay, I mean, we can try Graffs Cluster and see what it looks like. Clusters are best on a night like this.
Yeah, I'm plus it's up, it's up pretty good and high in the sky, so less atmosphere.
Yeah, less atmosphere, but we still have moonlight.
Yeah, still have moonlight, but we can see. I
all,
can honestly say I've never looked at the Graffs Cluster.
Yeah, we all be going. So what we're doing is we're getting a star in the view, which is this guy right here. Okay, it's bringing this star in, OCAB, and it's going to try, and it'll use OCAB as a focus star. And once OCAB is in, then it runs off to Graffs Cluster, knowing full well where it is from that position. That's, again, it's the high precision pointing.
This is going to be one of those areas that you just need to take a little bit of an exposure, I bet you, and it's going to pop.
Maybe.
Hopefully.
We're invisible light only. I have to put the... no, actually, I got the other... I got that. I'm going to take a visible light shot. I'm in... Let me go back to the narrow band, and then go one more to the through the tube view. Okay, and there we go. So now you can actually see the cluster. And let's just actually do... Let's do 4,000, no, 3,200. And we'll do 10 seconds. Let's just see if we're in the right neighborhood.
Yeah, see what we got.
See if we're in the right neighborhood. Think we'll be.
Darn close.
Yeah, I mean, there's a lot going on in here.
Yeah, I know, right? Didn't expect it to be that active.
No.
But okay.
So, oh yeah, that's beautiful.
Oh wow.
Yeah. This is the summer Milky Way is all throughout here, so we're actually able to see. Here's the cluster right here.
I vote for longer exposure.
Yeah, you want to go longer?
What did you do on the last one? 10?
This was 10 seconds, but only 3,200. We'll crank this up to 5,000.
Oh, okay.
And we'll go to 15 seconds.
Ooh, watch this.
Yeah, watch this. Here we go.
Watch this.
Who says that?
Like bling.
Yeah. Well, it'll be a little bit brighter. The stars look very different to astronauts than they do to us, because the atmosphere bloats our stars. Yeah, see you can see the visual appearance here with visual light. It's not as exciting. Well, it looks nice. I mean, it's really pretty. But let me do one thing. Let me actually go back to...
Well, you go from what we initially looked at with the naked eye, just looking over that, and to that, realizing all that's there without,
Oh, yeah. We're looking at this, this is what's really there,
Yeah.
Beautiful, and then
probably even more than that.
Maybe so. And what I'm gonna do is actually I'm gonna change over now to the wider narrowband filter, which is filter number 2, and you'll see stars in here. And then I'm going to do a focus on there. This is my focus square right there. And I will bring one of the stars up that I want to focus using this filter. We have to focus between each filter because of the fact that the light focuses at different places depending on
what was
the
this?
frequency
Is this Graffs
of the
Cluster
light.
or Graffs Nebula? Graffs Cluster, right?
This is the cluster, yes.
Okay. Yeah. I just want to make sure I had the name right.
Was this Graffs that we're looking at?
I thought that's what we were looking at, but
That's the Tweedledum Cluster.
Tweedledum Cluster.
Yeah,
Makes sense why I was attracted to it.
yeah. Well, actually, it makes perfect sense.
Right.
It's a great cluster. All right, so let me focus here. I got my focus star in there. And let's go focus. Let's go focus. Ooh, that's already looking pretty good. All right, let me do this again. Goes out of focus, and you see less stars when it goes out of focus. Bring them down.
Yeah, Graffs Cluster is an open cluster.
Yeah, these are open clusters. Okay, this looks interesting. Let's see if this gives us what we want. All right, and we're going to do 20 seconds now. And off we go. 20 seconds at 5,000 on the Tweedledum Cluster. If Daryl was here, he would be shaking his head going, man, why do they have such silly names for some of these clusters? It's NGC 6633, actually. And we'll see it here in a moment. So as you can see, we have our interactive planetarium that follows around with us so we can actually see what's going on. Well, there you go. So you look at it. Now you can actually see the cluster.
You know, there's a guy that does David's Astronomy that does something called Sky Tours.
No.
Yeah.
Well, I mean, it's sort of a...
I won't, but it did come up.
It's a well-known thing, I guess.
Yeah.
But we do SkyTour LiveStream and SkyTour Radio, and if somebody wants to do SkyTour Cadillac, they can have SkyTour Cadillac, you know?
Looks like this guy's been doing it since 2012.
Okay.
But he just has it as like Sky Tours up there, you know, summer star clusters and all
Yeah.
that stuff.
Well, I mean, people want to see the sky. Maybe they'll call it that.
So we got M8, M23, M26, M11, NGC 6791.
We
Are
got,
these things around the Tweedledum cluster?
We got plenty of things. Actually, let me back us
Like,
out
I'm
here.
just wondering, are they named after other fictional characters, other Lewis Carroll characters?
This is also called the Captain Hook
Anything?
clusters, just so you know. So that's pretty interesting.
Where's the Tweety Bird cluster?
Right into the Sylvester cluster. I don't know.
Oh?
No, I don't know. That's bogus.
It wouldn't surprise me if there was a Tweety Bird cluster.
Bogus. Now, actually, you want to see Graffs Cluster?
Ooh.
That's this one right here. Let's just go to Graffs Cluster because you asked for it before, and I lied and brought you to a different one because I knew the Tweedledum Cluster looked better.
Let's see, Tweety Bird cluster.
That's funny.
It just looks like balloons.
Here, I'm gonna take an exposure while it's actually moving around, so people can see all these streaks and everything. So it's you'll see it'll show you the motions that the guiding telescope has done.
Yeah.
So it's zipping things around. All right, well, we should be almost done now. Uh-oh, we have dome.
Uh-oh.
Yep, I have to go move the dome.
Well,
I don't know if I have to. That maybe that's clouds.
You think so?
No, that's gotta be the dome. It's gotta be the dome. But we see what's going on here, so I'm not sure. Let me take another shot because the star it went to is not necessarily where the cluster is. It could have been off into the netherworld, but right now, if we look down here in our telescope view here, you can actually see that the telescope looks like it doesn't have the dome in the way, but we're gonna find out right now. Yeah, see?
It's close.
No, it doesn't. It's not bad at all. Okay, because the star it was using to line up the cluster was actually farther outside the observatory dome.
Right.
Yeah. I don't know where the hour. I gotta see if the hourglass is up. I gotta look that up. This is in response to Genghis looking for the hourglass, but unfortunately,
Does he mean the dumbbell?
maybe the dumbbell is up. If he's talking about that, you know.
I don't know.
Yeah.
Hmm.
I mean, we can look at the dumbbell if you like. I just have to look and see. We might end up having to move the dome again, which is okay. I don't have a problem with that. But it's still a pain. You gotta go out there and dodge the darn bears and all that. I think my favorite star is Albireo here. We all like Albireo. And let me this one's cool, and I want to show you this if we can do it. We'll see if we can do it. Okay, we'll try this one first. We'll try the dumbbell and see if we can do it. But we gotta watch the telescope to see where it's going to make sure that. All right, I'm liking it so far. There's Albireo. It uses Albireo as a target star for the high precision pointing. Albireo is a beautiful star pair. They're 5,000 astronomical units apart.
Mm-hmm.
They're stunning.
Hmm.
Interesting. Okay, so now if I go back and look here where we're looking, we should be on the dumbbell right now. And 20 seconds at 5,000 should show it to us. So I'm going to take that picture. Sorry, I'm getting tired too because I was up till like 2 in the morning.
Yeah, don't let us keep you up.
Nah, don't worry. I'll let you stay up and run the telescope. I'll go to bed.
Ooh.
Actually,
Ooh.
when we're in Arizona, you know, that is something you'll be able to do.
Yep.
I can let trusted people run the observatory, and I can head off to bed if I want to.
Trusted people.
I know, that kind of eliminates you. I realize.
Hey, do you want to see how fast this telescope can 360 around the dome?
Yeah. Yeah, but
Let's see how fast we can smack these two telescopes
I
together.
but I think, well, no, there it is. That's beautiful.
Earthquake test.
Yeah, earthquake. That's funny.
Genghis is asking something very specific to you, Mark.
Okay.
I'm not sure if you know the Daryl movies or Explorers. Said he heard they might be redoing them into a miniseries. He's talking about like different ships from those movies.
Oh yeah, the Explorers movie.
The ship from Explorers, yeah, the Thunder Road, and the Eagle 5 from Spaceballs. I was wondering if you can 3D those. I guess if you have the blueprints or schematics or whatever you want to call them.
Yeah, they can be 3D printed. They might actually have those on Thingiverse, Thingiverse.com. Look it up and see if it's there. If it is, I'd give it a go.
Thing A or I?
Thing
verse?
I, yeah, Thing I-V-E-R-S-E, like universe, but
.com?
Thingiverse, yeah, .com. And we have a prototyper here. We have several. We have one that's just a FDM, and it's a a filament deposition printer, so it has a filament. And we also have an STL printer And the STL is what we do the craters on, and the resolution is just stupendous. Imagine a resolution that's 0.05 millimeter. Okay, so it's 5/100ths of a millimeter per layer. That's a really, really fine resolution, and that allows you to have a lot more, or show a lot more detail. Okay, we're gonna go here. This should put the Dumbbell Nebula in the middle right now. If I want to see where it is, I just got to go into 4K video mode here, crank up the ISO for a minute, and go see what we got. I'm expecting to see that. Yeah, there we are. There's the dumbbell right there. Okay, so what we do...
A little bit of dome on the side?
No, actually, that's amplifier noise built into the camera. It's a camera artifact.
Oh.
For a camera this sensitive, you're going to find that you have some noise from the camera creeping in, unfortunately. Okay, this is going to be, let's see, 25 seconds. And, oh hell, 30 seconds at 8,000. Here we go. We should have our guide star right now.
Do you think you are going to move the dome at any point, or?
Yes.
Okay. So I got nervous and I looked up a story, but I kind of want to ask you about it before you go out. So.
Oh, ask me then.
Did you guys talk about Perseverance?
You mean the? No, we did not.
Can we talk about Perseverance? What do you know?
Oh, well, first of all, look what I know here. Wow. Now, can you talk about that in a minute?
Of course.
Okay, this is the Dumbbell Nebula. As everybody knows, the Dumbbell Nebula is a planetary nebula, and when we look at a planetary nebula, and we look here, this guy right here, this is
exactly there, folks.
Right
exactly there.
Right. This is actually a white dwarf, the remnant of the star that once was in this region. And that star, when it expanded, as it ran out of hydrogen fuel, the star ended up puffing off its outer layers. And some of the stars do this in a way that's not symmetric, okay? But more layers come off, say, around the midsection, and they blow off to the sides than the poles or whatever. And that's what we're seeing here. And we call these types of nebulas, the planetary nebulas that they are, bipolar nebulas. And the bipolarity is based on the fact that it's a top and bottom or left and right sided dominance of the matter that's being blown off this star when it was popping off its layers. And the stars, they do this. The stars expand and they contract, and they expand and they contract. Imagine every time they expand that they puff off some of their stuff, and then the rest of the star contracts inside, puffs off some more stuff, contracts inside. So you get these concentric shells around normal planetary nebulae. But if they have other things going on, like maybe the star is a rapid rotating star, and maybe some of that material, because it's spinning faster at the equator, goes off faster at the equators and causes this type of thing. Maybe this is the North Pole, South Pole, and it was spinning this way really rapidly. And so the stuff goes off more in a much more asymmetric manner like this. All right. So this is the beautiful Dumbbell Nebula. We're using a narrow band filter to show this. You can see these red areas here, from it's neon and hydrogen. This is the oxygen again, the ionized oxygen. You can see the modeling in here. We have the moon out, and to do this with the moon out shows that we're actually really, really able to capture a beautiful nebula tonight, even with the moon out. That's very important, you know. So that said, what we can do is we can now that I know that this is working nice, I'm going to try to do another one. And we're going to go to 1 minute on this. And we'll do 10,000. We're going up yeah, we're going to try and pull in some detail here, you know. You okay, Keith? You all right? You hanging in there?
Yep. Just getting here, checking the Facebook pages.
Okay.
That's for Imaging Live and SkyTour.
Okay. Oh, I didn't update the addresses up there. I don't think I still got to remember how to do that. I can't do it. Did you do that?
What?
Did you update the links?
It was such short notice. I didn't get a chance.
Okay, that's fine.
But, yeah. We'll figure out a way to get those to auto update somehow. Hopefully. Might have to talk to a programmer actually and just see if they can find a workaround.
Yeah, maybe.
It'd be a lot easier if it just automatically updated to the newest or while you were live and just kept that one up until another one comes.
Yeah.
But for some reason, it won't allow you to do the, Mark D'Antonio /live like it does everywhere else. Yeah. I don't know why, but.
Well, we'll have to find out. Maybe we actually have to call the people that we buy the website from.
Yeah, I mean, we might have to. Because I've tried it every which way. I've tried the live links. I've tried, because they did have a mobile one, and I was trying to link to that, and that didn't work. Like, I spent hours trying to figure out how to add live links to automatically update, and I just, and the back-end code, I think, is CSS, so they might be able to do something with it.
I'll be back in 1 sec, guys.
Oh, no, you can't go.
I'll be back.
All right. You're going to miss the 1 minute result. Here it comes. Let's see what we get.
I would like to say hi to, what's that lady's name, Mark?
Where are we looking? Brandy? No,
Mrs.
Mercer?
Mrs. Mercer. Hello, Mrs. Mercer, if you're out there listening.
Mrs. Mercer, Keith and I think you're okay.
Yeah. And entertaining.
Yeah. We watched all your videos.
Yep.
Yes, we have. If you guys haven't seen Mrs. Mercer, go look her up on YouTube. Check her out. It's really quite funny.
Yeah.
It's some of the things we've seen, I'll tell you.
Yeah.
It's all good.
I think I literally watched like a Thanksgiving of like 7 hours of nothing. But I was fascinated by it. Like, she just left the camera on and we just, watched the cars go by.
Well,
it was great.
If you think about it, it's actually somewhat ingenious.
Yeah.
She didn't have a security system, so she points the camera at the door and turns on the YouTube stream.
Yeah.
Someone breaks in, they're going to get broadcast to the world, man. That's really a cool idea. Oh, I guess we just got a little bit of a problem there.
It looks like denim.
It does, doesn't it? Yeah, see, the moon is causing that blue. That's one of the things I was trying to do was test that. But okay, let me. We're gonna try something a little different here. We're gonna go into the computer, and we're gonna go down and down.
And by the way, for anybody in the Central Plains, watch out. By the end of the week, they're talking about a lot of rain falling.
Oh, I thought you were saying you're heading out there or something.
No, I'm talking Kentucky, Tennessee, Iowa, Illinois. They're talking over 5-6 inches of rain in a very short time. So,
wow.
Is flooding is definitely a possibility out there.
Is there like a
I'm not sure
storm
exactly, but
coming through?
Calling for a lot.
All right.
So, just a heads up.
Kingus. Okay, we're going to just try 30 seconds now on this nebula. I just changed some of the guiding parameters to see if I was along the right path there. Huh. Yeah, I think I am.
And by the way, guys, we're not joking. If you go over to Mrs. Mercer's channel, just leave her some love on there. You know, God love her.
Yeah. She's
she is a subscriber here, and you know, we just kind of ventured off and checked it out one night, and we just thought it was great. So, you know.
Yeah, you know what's funny about it is you watch her. She, you know, her and her husband they live in a trailer park. They have next to nothing, and this lady never stops smiling. She's always smiling. Nope. She always has a smile for you when you come into her house via YouTube. You know, and it's really interesting to watch. And you know, Keith and I actually donated some money to her because we thought it was just like, wow, yeah, you know what?
You know, how could we not? It's like we were getting entertained out of it, you know, and it's like, okay, well, you know, you saw some videos of back in the day, you know, where it was like a year ago and they didn't have enough money to go like grocery shopping and stuff, and you felt kind of bad. Like, well, what if we just gave her a little boost, you know, just to have a boost, you know, just out of nowhere, not expecting anything in return, just, you know, just kind of as a thank you. And she messaged both of us individually and said thanks because it totally took her by surprise. So, you know, you love, and as we said, the lady always has a smile on her face. Nothing ever brings her down, no matter how bad it was getting. You know, she was always upbeat, and so you know, me and Mark gravitated towards that, and you know,
we just thought that
there's some love in her comments. She loves comment.
Yeah. Yeah, I don't know. I just couldn't.
It's Mark Center.
I just couldn't consciously deal with someone who couldn't go buy a bottle of Tylenol because they didn't have the money.
That's what it was.
And that was like, oh, come on. Are you serious?
He had an abscess or something, and she couldn't buy Tylenol. I was like, what the hell? And granted, the video was old, but we were like, you know, that shouldn't happen to anybody.
No, I agree. And
just decided to give her a little boost. Yeah. Nothing big, you know. It wasn't nothing, you know. But it was just our way of saying thanks for the entertainment, because she is entertaining when she gets on a roll with us. She's very
Who's entertaining?
What's that?
Mrs. Mercer.
Who's entertaining?
Mrs. Mercer.
You got to go subscribe to Mrs. Mercer, Danny Van.
And if any of you guys go to subscribe to Mrs. Mercer, tell her Keith and Mark sent you.
Yeah.
From SkyTour and P&K Space Imaging. Yeah. She'll, as I said, she loves comments and stuff, and it keeps her going. It keeps her interactive with the people. So, yeah, good lady. Once again, always has a smile on her face, no matter what's going on. Even if she can't buy Tylenol, she's always got a smile on her face. So,
she's she's amazing that way. And that was, like I said, that was a linchpin. Hearing this,
and there's no better community to do this, to go over and say hi and just give her a thumbs up and everything than this community here, because everybody here just is subscribed to everybody else, and we all kind of hang out together. So it's a good community to have the backing for.
Thanks, Sean. That's very kind. Thank you, man.
Hi, Farva. Thank you.
Thank you, Farva.
Actually, Farva, that's a good question. And I'll answer that right now because there is. Oh, man,
can you read the question out loud? Because in case people are just listening and not reading chat. Thank you.
Instead, I'm looking at, as Keith said, denim on the screen here.
Yes.
I think I figured out what's going on here. I went the wrong way. Okay.
You want me to read it?
Yeah, why don't you read it while I go back into the computer here and adjust.
All right. Farva asked, why is this incoming debris field and asteroids being pushed so heavy on the YouTubes? What is the real story?
Well, the real story is that there is no debris field heading toward Earth at all. Okay, it's just YouTube people just brandishing the sword of false information and sending it your way and hoping that it cuts you, So the real story is there's nothing damaging coming our way. What they do is they took and conflated a story about an asteroid that was going to pass close by the Earth, which, by the way, happened 4 days ago, so you know. And then they turned it into a debris field, and before long, it probably would have become a deadly swarm of asteroids heading to Earth under intelligent control. But the truth is, it was really an asteroid that was close to the Earth by astronomical standards. And what does that mean? It means 14.5 times the distance to the moon. Okay? That's what it meant. not between the Earth and the Moon, not grazing our atmosphere, but 14.5 times the distance of our Moon. That's how close it passed. For an asteroid, that's pretty close, you know. But that's it. There is no story because it was made up to begin with, and they just piggybacked on the fact that an asteroid, a singular, not plural, singular asteroid, was passing at that distance from Earth, and they turned it into a possible asteroid that's going to strike the Earth, and then of course it's carrying a giant batch of debris behind it. Nonsense. It's not. You know, I've looked into these things. I don't. You know, I when people say these things, I always say, let's find out the truth. The truth is always somewhere in between. You know, if it's not an asteroid, it's a swarm of asteroids. So the truth is somewhere in between. It's an asteroid, and it is close by astronomical standards. But that close is not close by human standards. So there's the story, Farva.
I finally found she changed her channel name. That's why I couldn't find her.
What'd she change it to? Oh, like Terry Lee Mercer or something?
Mrs. Terry Lee Mercer now.
There you go. That's right. I saw that.
So there's the link for her page, guys. It's in the chat.
Yeah, we like her. She's great.
Yeah, I mean, just, as I said, entertaining. I mean, I found it completely enthralling.
Yeah. Her husband's there, and he doesn't really interact with the camera too much. He sort of sits in the background most of the time. But you're getting a slice of life from somewhere in Alabama. We know the town. I think we figured out the town. Keith and I drove to the house, actually.
Yeah, we're trying to anyway. We were like, man, we got to find out where this is.
We found it, you know, and there we were, sitting right out front of the house. Look at that. That's our house. We even recognized the door and everything. Remember that?
Yeah. Yeah.
No, we did this on Google Earth, of course.
So, yeah. So people, astronomy people that come around us, just go give the lady some love.
Yeah.
Spread good vibes.
Whatever that means to you.
Yep.
Whatever that means to you.
Well, I will warn you, don't worry about getting caught up in the Happy New Year's or the Merry Christmases or the Thanksgivings. They're just basically a webcam being used for security cameras. But everything else is great. Have fun with it.
Yeah, as I said, that was really kind of somewhat ingenious of her, just pointing a camera at the door, the only way in. And if someone's going to break in, they're going to come through that door, and she's going to catch them on camera, and the whole world's going to see. She'll still lose all their stuff because they're going to steal and rob, but you're going to see them, you know, and you'll know when they did it, what they took, roughly, how long they were there.
The computer. But
again, come on.
You know, it's always going to be on YouTube no matter what.
Yeah, that's right.
Yep.
Okay.
So just tell her we sent you and show her some love, and hopefully she'll see it. I see it. She probably hasn't uploaded in a while.
Yeah, I don't think she has.
It's like 4 months ago. So, but she'll see it because as soon as me and Mark did that, she did write us the next day. So she does look at it.
Yeah.
So hopefully that'll make her day and give her a good tomorrow.
And tell her Keith and Mark, Keith from P&K and Mark from SkyTour LiveStream. She actually joined our streams, which is why we know she's there.
We were just looking up random, like you people that are in the chat right now, we just look up random people, like once the stream is done, and just, see what you got. And we came across Ms. Mercer one night, and we were enthralled. And,
you might say that. It was just like we got to go see this. We got to go see what she's doing.
Yeah. Yeah. And it turned out to be a gem. Diamond in the rough.
Yeah. A lot of fun.
Lot
of fun.
So it'll make her day tomorrow. Hopefully she has her YouTube things turned on, and all of a sudden she hears all these dings coming up of people subscribing to her, leaving her comments. That'd be great. That'd be awesome. Yeah, and she won't who the hell are all these people writing me? And not who are these mother? She doesn't do that. Yeah, she's actually very, very straightforward, and like I said,
it's fun. It's just fun listening to her talk. You know, she doesn't have a bad word to
not,
say.
You know.
Yeah, she doesn't have a bad word to say, even though life has thrown her all kinds of crap. You know, she doesn't have a bad word to say.
Yep.
You know, which is kind of cool. Okay, this my guiding system is giving us some headaches here today. So let me try going here for a minute. Okay, we're gonna zoom away from the dumbbell for now. We'll catch it on a better night, and we're gonna look at Albireo now. That's Albireo right there. Hey, look out! Ow, ooh, that's hot. You know, this star system right here is really just a really beautiful star system. It's actually, you know, it's a K star, which is this orangey one right there. That's a K star, and this is a B star. And the K star is a K3 giant, I believe, and the B star, this one in this little one here from the left, that one's a B star, a blue B star. I think it's a B8. So it's a giant star next to a regular main sequence star that's actually, you know, this guy has used up all its hydrogen, and he's in the process of heading to red giant stage if he's not there already. I think it is. And this one here is still on the main sequence with hydrogen being fused into helium. So Albireo is just a real fascinating star, and I'll show you why if you haven't remembered or if you haven't been here in a while. Let me show you why. That explains why it was way down there, because I was using the wrong scene. Okay, so let's say 15 seconds at 10,000, and you'll see what's going on. So Keith, when's the last time you could stream?
What's that?
When's the last time you streamed?
Last night.
You did last night?
Yeah, we were on for like an hour, and then the clouds came in.
That's too bad.
That's a beautiful image.
It sort of is, but I gotta get rid of the guiding error here. I'm trying to figure out why that happened. I've been going here to try this out. Okay, so that's a north-south error. Okay. I'm jumping into the computer here. Not to worry. Don't worry, Mint. Oh, I'll be off. No. 7.
Yeah, and to Ronald, to your question in the chat, I think YouTube allows you to do 12 hours straight before it resets into a new video, then it can process. So I think you can do 12 hours.
Ronald asked that?
Well, he asked how she had over a 9-hour New Year's Eve show.
Oh, yeah.
Quote unquote show.
And she does.
Yeah, she has 11 hours on some of the other one. But
yeah,
it goes to 12 hours, and then YouTube automatically stops it and starts a new one automatically.
Yeah.
Process to 12 hours.
And then when you go watch those videos, it's like there's activity, at first, because she's talking at the camera and saying, okay, and we're going out now, and then she closes the door and everything gets dark in here. For the next 4.5 hours.
Priceless.
It is.
Love it.
Yeah, but you know what? She had some pretty faithful followers that would watch to make sure nobody broke in.
She has like 440 subscribers or something like that, and she's really active in her comment section. Like, she writes people back. I miss everybody that comments and stuff.
Yeah, it's hilarious.
Can't ask for a better YouTuber.
No need.
I don't do that. This is Mercer.
What's that?
Nothing.
Okay.
What are we looking at now?
This is Albireo. You see, this is the K3 giant right here.
Ronald's watching. He's like, how long do you watch to see if anything happens?
The whole time.
Go to the
I'll
other
watch
video.
what?
Ronald. As I said, the three,
Mrs. Mercer.
yeah, the three are just, security cams. But if you watch the other videos, she's actually talking to the camera. They're great.
Yeah.
Oh wow, look at that.
What?
The shot you just did.
Well, it's been up for about 30 seconds. You've
Yeah,
been
but
looking at
wasn't that
YouTube
clear?
again.
Oh yeah, maybe it was. Distracted.
Yeah. So this is that K3 star. I believe it's a K3. I'm going to check it out now again, just make sure. Because and what it is it's a K2. Okay, it's a K. Is that a K2 2? Interesting. Yeah, it's a K2. All right, K2 2. So it's a giant, super giant star, right? But next to the supergiant star is this blue star. It's a type B, and I believe I'm trying to find the type for that one. I think it's a B8. Either way, it's 385 light years away. It's actually pretty far, and at 385 light years, I did this when I was doing this in the dome. We know the separation between these two stars in what we call arc minutes. That is, a coordinate system superimposed on our sky. And when we can calculate the arc minutes between the two, and we know it's 382 light years away, we can figure out the real distance between the two. And the real distance between the two is over 5,000 astronomical units. Now, our solar system goes out to 100 astronomical units, maybe a little more. And then there are long period comets which go out to 700-800 astronomical units. In fact, Neowise is one of them. It goes out 715 astronomical units before it'll come back. That's a 6,800 year round trip, by the way, before it comes back again. So at 5,000 astronomical units, this thing is going out, obviously, many times the distance that Neowise is going out from our star. So we know that if you were at, let's say you were at the B8 star, say you were on a planet around that star, how big would the K2 look in your sky? It'd be the brightest star in your sky.
I'll be right back.
Okay, you'll probably see it during the day. But you probably won't see the star with your eye. You might see it as a small, tiny disk. It'll probably be, it's a giant, so.
Uh-oh.
What?
Your audio just dropped.
What do you mean my audio dropped?
I didn't hear anything you said. I can now, but
Okay.
I just lost that last sentence you said. It was like you froze for a second and then came back.
All right.
Could you repeat what you said, please?
I don't remember what I said.
Oh,
No,
I'm sorry.
I said that the stars are 5,000 astronomical units apart. So if you were at the blue star, the orange star would be a disk size in the sky, and as a giant, it might be larger than, larger than say the sun, but it would still be just it'll be the only star that would be a discrete disk, and it might throw some faint light on your planet as well. But it's going to have a tremendous luminosity because it's so big. All right. On the other hand, if you were at the K2 star and looking at the B8, well, then that star would look very, very small because it's only it's a regular main sequence star. It hasn't bloat it into a giant at all. So you'd have that going for you. Just so you know. I mean, that's kind of cool. It's just sort of a neat stuff, you know?
It is.
Yeah. So, that said, what do I want to do now? I want to come off of Albireo. And let's go find another spot. I really do want to show the Ring Nebula, but it's up there. It's going to be right near the... This actually should be past the zenith right now. Yeah, so that's the Neb right there. The Neb and the Veil. Yeah, I don't want to do the Veil because the moon's out and that'll be just a terrible view. So we can just hop over here to the ring, but I'm going to go to this star first. I've identified a problem with the you'll watch Albireo disappear in just a second because I'm telling it to go now. So Albireo is going to jet away. Phew. All right. I identified a problem with trying to get to the Ring Nebula. The database is actually incorrect. And if I go to Sulafat here, this star, and I say, okay, we're going to go to Sulafat, and then I say to go to the Ring Nebula, it might take us to the wrong place. It's really odd how this happens. It's just an oddball thing that happens. And it's not my fault. It's not the telescope's fault. It's just that the database was incorrect. So now that we have it and we're set to go here, I'm going to say go to the ring. And if it lines up on Sulafat, then it might actually be able to take us there. All right, so let's go and see what happens. It may use Sulafat. Yeah, see, it's going to use Sulafat as the precision pointing star. And then from there, we should just go a short distance. But if I go to Shiliak, okay, yeah, I think it's going to find it now. If I go to Shiliak here and tell it to find the Ring Nebula, it goes way out. It goes way out. Shiliak, this star.
Shiliak.
Yes. If I tell it to go to Shiliak and find the ring, it jumps out here somewhere. So we should have the ring in here right now. We'll do 20 seconds at 10,000. It should be pretty bright. So, let's see here. Where's my ring? There it is. So we have our ring right down there. There you go. That's really pretty. Yep. And we also, it's not quite doing its thing. I gotta still work on that guider. So sometimes the guide system just has its quirks, you know. I'm hearing thunder, or Keith is breathing in the mic.
That's not me. I got mine on mute.
Uh-oh, I hope it's not me.
Oh.
I don't usually breathe on the mic, do I?
No.
I kind of hate this new headset, though.
Oh, maybe the headset's doing it.
Mm.
Maybe. It is Queen Amanda.
Yeah, usually I stay on mute, but...
Oh, no worries. You don't need to stay on mute.
Anyway, speaking of things people stream and all the channels you should subscribe to,
yeah.
Can we talk about Perseverance and who might be streaming that Thursday morning?
Boy, I don't know.
What is a Perseverance and what am I missing?
If you stream it, nothing.
Oh.
Hint, hint. It's going to Mars. So it's spaceship going to Mars.
Yep.
I don't know if a spaceship, not spaceship, rocket. I don't know.
That seems like something that's right up a Bill's alley.
Yeah, he.
Well, I'm gonna say.
See, he tends to
20
stream
after
those things,
12.
and then he has to delete the streams after because it's copyrighted material.
Well, no, if he's doing a rocket launch, he usually does it on the Skywatcher channel, I believe.
Yeah.
If you go to nasa.org, if it's for educational use, you're allowed to use it, copyright free.
Yeah.
Oh, okay. Well, maybe so, huh? Yeah.
Hold on, I'll message him right now.
We always got written permission when we did NASA stuff, just as a safeguard, but they told us that we really didn't need it if we didn't, But we always got the written permission for it. And it's not hard to get either.
Well, the Mars Perseverance rover, this is heading to Jezero crater. And Jezero looks like it's right on an outflow where an ancient water runoff was. So I'm guessing we'll probably see similar stuff to Gusev crater and potentially Gale crater with the other rovers. It'll be interesting, But there's some interesting stuff,
Well, I just wanted to find something to talk to Keith about when you went to fix the dome, but then when I saw this article, I was like, wow, how exciting. Why is this the first time I'm stumbling across this article? They said something about they're going to have a little helicopter.
Yes.
And they're going to try to fly it, called Ingenuity.
Yeah.
And it's going to attempt to fly the first on another planet. Yeah,
That's
and
right.
have a robotic arm, an array of cameras, and a pair of microphones.
Imagine how hard that's going to be with the delay.
Well, it's all programmed.
Yeah.
Well, what would be interesting is if they can get the, first of all, the helicopter will work. And the reason is because it's going to be flying in an atmosphere that's way thinner than ours. So that the pitch of the propellers and the size of the propellers all have to be adjusted to that particular atmosphere. The pitch has to be steeper, the propellers have to be larger to catch more air. But the thing about the rover is it's going to be looking for signs of life like the other rovers, and it's got a lot of really cool instrumentation. Right now we have the most complete science lab in the entire solar system on Mars, and that's on the Curiosity rover. Okay, and Perseverance is going to be the next step, the next level beyond Curiosity. And Curiosity's been there since, I think, 2012. So
yeah,
it was only meant to be there for 90 days.
Yep.
Yeah.
It's amazing.
Yeah.
Exceeding expectations constantly.
Yeah.
Yeah, this one says it's going to look for evidence of ancient fossilized bacteria.
Yep.
As well as gathering rock and soil samples.
Yeah, isn't this one, it's supposed to come back?
I don't know. I didn't read that far into the article. I'll let you know. Hold on.
Or we're supposed to send something back? Maybe not. Maybe it's not this mission.
I saw another article saying we're going to try to return a rock we got from the moon or something. I don't know.
I
didn't read that article.
I think that's it's the asteroids. Is it Osiris-Rex at Bennu and the Japanese mission at Ryugu? That mission, they're sample return missions, and but that's asteroid sample return.
Right.
I don't know of any Mars sample return.
Yeah, as I said, I just started passing. I didn't,
Yeah.
I mean, I'm out of the loop anyway. So.
Yeah, and the States are the third nation to embark to Mars this month. China and United Arab Arab
Emirates.
Arab Emirates. Thank you.
Yep.
Lunch from Japan. Yeah.
Right. And they're going to join us and other. First of all, keep in mind it's not easy to get to Mars. It's hard. Getting to Mars is hard. Landing on Mars is harder than landing on the moon. On the moon, we have to power all the way down, but that actually gives us a level of control. On Mars, there's unknown things that can happen with the atmosphere. And, you got to deploy a parachute to slow you down. Mm-hmm. And I just thought that the...
Random dust devil,
that's correct. I just thought that the delivery system called the Sky Crane, I think that was for Curiosity. Was that Curiosity's? Sky Crane,
yeah.
Right?
Yeah.
And what it does is it comes down, it has a parachute that's deployed to slow down this instrument package, and it's coming down through the atmosphere. The parachute cuts away, and this thing opens up its rockets and starts to fire rockets to lower down to the planet, and then it dribbles out from underneath it on a tether, the actual rover. And as soon as the rover touches the ground, this thing cuts away and goes shoosh, and flies away and crashes. And it actually caught, when the Curiosity landed, it was snapping photos, and it actually caught the Sky Crane delivery system crashing in the distance.
Didn't they call them the jolt thrusters? Like as soon as, because it was an exploding, like a pack that disconnected the cable to the rover, and then all of a sudden the jolt thrusters hit and just shot it out, at hundreds of miles an hour just to get it away from the rover.
Yeah.
Yeah. Yeah, but they actually caught the crash with the one of the cameras.
Yeah, I thought that was pretty cool. You actually see the crash of this this thing. You see a dust cloud in the distance.
There was $1 million.
Oh, $1 million? What are you talking about? Jesus, that was probably like $100 million of development. Testing, had to test it first.
Yeah.
Did you see chat?
Yeah, you know what, Mark? See, I was right. Humans are about to return a rock to the surface of Mars after 600,000 years. So the rock's going back to Mars. Turn a rock to the surface of Mars. So they're not bringing about... Yeah, so we're taking one back.
It's a meteorite fragment. It says it left Mars 60,000 years ago and arrived on Earth about 1,000 years ago, and we will be bringing it back Thursday. If we launch Thursday, how long until we get to Mars? 3 days?
It's probably going to be... It could be anywhere from a few months to over a year and a half, depending on where the planet is relative to Earth and how much braking the spacecraft's going to have to do to get into a Martian orbit, Mars orbital insertion.
Far away.
You know what? I think I do remember seeing this story a few weeks ago. Is this the one? It can either happen Thursday or not until like 2023 or something, or like several years from now.
Yeah, because it has to be at what do you call that, Mark?
A certain angle, yeah.
Yeah, and Mars has to. We have to be on the same side of the sun as Mars, basically.
No.
No. You're talking about conjunction.
Yeah, something like that. Had to be close and on the same side.
When Mars is on the same side as us, then when we launch, we have far less distance to go. But if we don't launch at that time, then it takes Mars like almost 2 years to go around the sun, a little over a year.
Wouldn't that be
something to do with going through the holes in the Van Allen belt or something?
No, I mean we know how to get through them.
Yeah.
Yeah, but I thought there were only certain times everything lined up properly for a launch.
Well, there might be.
I don't know. Anyway, go on. Sorry.
I don't know. Actually, I mean, I'm not aware of any issues with the Van Allen belts. Here's another. This is the Ring Nebula. Okay, and
wouldn't it be something if like they're sending this and everything's going good, and all of a sudden that thing hit the Tesla floating through space?
Oh God!
It's like a random encounter with like a car.
And the last thing that the rover, last thing that the Perseverance rocket sees is Starman,
Yeah.
like this, floating through space away from it.
The dancing hula girl on the dashboard. That's oh my! Could just imagine the one thing that would hit that Tesla would be the expensive space.
That's hilarious.
Oh yeah, let's hope not.
It won't.
Yeah.
It's nowhere near there. But here's a ring nebula, guys. This is another planetary nebula that's really interesting nebula. They say it's actually deep, okay, and long like a barrel. But honestly, I don't think it is. I think that we're looking at expanding concentric spheres. I think it looks the same from all directions you look at it, because when the material is on the sides, okay, you can't see through my fingers here, but you can see through them on the ends like this, okay? So when the material is like that, you can see through it. Thus you see this kind of little light area, but it's still blue from the oxygen in there. But as you come around the sides, it gets thick and you can't see through it, just like here. Then you get in the front, okay? And again, you can see through it. And I think it looks this way everywhere you look. But that's my theory, and I'm sticking to it. I'm Ann Elk.
Hey, sounds plausible.
Yeah. But I am going to have to shut down now, because I have to go and take something for my headache. I've had a really bad headache that's been ratcheting up as the night's gone on. And
No
I
problem.
hope it didn't start when I joined.
Oh no. You never give me a headache.
Okay.
No. Not at all. Keith did, though. No, I'm just kidding.
You're welcome.
No. But hey, folks, I want to thank you for joining the SkyTour LiveStream with us. Make sure if you haven't subscribed that you do go out and hit that subscribe button. Then hit the like button if you liked it. If you didn't like it, hit the no like button. Okay? The down. The no like button is the one that points up. Yeah. They both point up. So.
Oh my.
Yeah, oh my. So make sure you check that out, and we have all these other streams out there that you can check out as well. We covered Comet Neowise pretty extensively over the last week or two. It looks beautiful. And to all of you in chat, thank you, my friends, for coming out. And on behalf of Amanda and our special guest noisemaker Keith tonight, I want to thank you for coming and enjoying the skies with us tonight. And Amanda, say goodnight, Amanda.
Good night, Amanda.
Exactly.
Amanda.
Good night, John Boy.
P&K tomorrow night, hopefully, if there's no clouds.
P&K Space Imaging is your one-stop shop for lunar viewing, as well as
Crater.
And crater dives are actually monumental. They're just beautiful.
Yep.
You zoom more than you think you can, and you go to P&K.
Super.
So enjoy your time. So, folks, I want to thank you for coming, and this is Mark signing off, and I will be back on the next clear night. And if that's tomorrow, it means tomorrow. Okay, once this observatory is duplicated in Arizona with this very instrument we're using here, we're going to have, how do I even say it? Absolutely stupendous views, because you see things in the sky so clear and so beautiful that we don't have a lot of the noise you see in the image here. We just have the image and the stuff in the image. We don't have to take images for as long because it's so beautiful. It's incredible, as you'll see. I look forward to showing it to you. But for now, you guys have a good night. We will talk to you on the next clear night. So long.